Doing? I started the recording. Yes. Hey everybody, we are live and in stereo. So now we're going to do the 2023 set for organic synthesis. And the reason why I'm focusing a lot on organic synthesis is because it completely encompasses every single chapter of organic chemistry. So just by doing these organic synthesis MCQs and organic synthesis theory questions, I'm actually ensuring that we are able to revise every single chapter. Although you might think, Satwariman, apni to alcohol abhi check nahi karaya, practice mein wo nahi karaya. So I'm continuously working on organic synthesis with you all so that all the other chapters get covered as much as possible. But obviously, I will also, when the time is near, when we are about to launch the past paper session for AS level students, I will also, work with you guys when it comes to all the other chapters as well. I've done almost all the chapters to some extent, but yes, I want to do more and more practice. Sir, will you conduct yearly papers? Absolutely, techno, but I'm just going to do the 2025 yearly papers because that's the only papers you need to be able to, get a taste of what flavors are awaiting you for the Cambridge examination. Other than that, for AS level chemistry, especially, I would suggest sticking to my topical booklet and my topical questions that I do with you all. The topical questions are from 2024, 23, 22, 21, and 20, and 18, 19, and so on and so forth, right? Because the reason why I focus a lot on these topic wise questions is because they fix your real concepts. They actually help you understand concepts. Because if you do, let's suppose you do 10 years worth topic wise questions, or maybe 10 years worth topic wise questions, it's far more beneficial than doing like 15, 20 yearly papers which do not cover all the years. Yearly papers is something else and covering all the years is something else, because in every single session there are three components effectively for your exams, right? Normally the 1 3 component is just like the 1 2. The 3 component normally is just like 1 2, but still there are three components. So if you just do all of these repeatedly, or if you do topical wise questions, the topical wise questions are far more beneficial for A level students. And then it's up to you what you want to do. Do you want to stick to somebody who's just gonna do yearly papers of the 2025 4 3 2, just going over them quickly, looking at the marking schemes and just writing the answers? Or do you want to stick to somebody who's just going to do the 2025 yearly papers, and then he's just going to continuously talk to you guys about theory questions to fix your concepts, the topic wise questions, sorry, to fix your concepts, to help you understand the basics behind every single question? That's up to you guys. That's up to you guys to decide which you're more comfortable with. So yes, and obviously, all of these recordings will be available as part of your yearly past paper session if I were to conduct a yearly past paper session, because even now I'm unsure, because I don't know whether I'll have the time to conduct it or not, right? But without further ado, let's just talk about question number 5, which is the 2023 set. I've shared the PDF with you guys in the chat, and it's also present in every single group I've sent it, right? So you guys if you guys, it's highly possible that you guys have joined from a respective group that I'm part of, and just like students add me to these groups, so you guys have the access to the PDF which I've shared with you all, right? Now, question number 5 says aluminum carbide reacts readily with aqueous sodium hydroxide, right? So I can say here you have Al4C3, which is aluminum carbide, and he's saying it reacts readily with sodium hydroxide, NaOH, right? Now, I think the products of the reaction, the two products of the reactions are, see, you don't need to know the reaction, hence the examiner is telling you what the idea is. So he's saying one of the product is NaAlO2. So one of the product is what? It's NaAlO2, okay. And then what's the other product? It's saying it's a hydrocarbon. Now I don't know what hydrocarbon it is, but hydrocarbon are compounds with carbon and hydrogen atoms only. So it's probably what? It's CX. I don't know how many carbons there are. I don't know how many hydrogens there are. I don't know. I'm doing these MCQs with you for the first time. Absolutely. So I don't know how many carbons and hydrogens there are. I'm thinking like a student, right? And he's saying water molecules are also involved as reactants. Now you Cambridge dumb person, stop playing psychological games with me. You could have also written water here. But see, he's written half the reactant side of the equation here, and one of the part he's given here that water is also involved as reactants. So if it's involved, you should have told this to me at the start. I would have made the equation a little more beautifully. But this is water on the left hand side. I've also written that since it's also part of the equation and it's also part of the reactions. Now, what he's saying is what is the formula of the hydrocarbon? So effectively, he just wants you to balance out the equation, right? Now, how do you balance the equation? Think about it. you have 4 aluminums on the left, you should have 4 aluminums on the right, but there's only 1 aluminum. So let's just balance out the aluminum. I'm going to write a 4 right here. Easy stuff, guys. Then you have 4 aluminums on the left and 4 on the right. And if you look at sodium, when you wrote 4 here, the sodium fluctuated. You have 4 sodiums on the right, but you only have 1 sodium on the left. So what should you do, guys? What should you do? You should add a beautiful 4 here, right? 4 on the left and 4 on the right. Now also try to understand that this part of the equation is balanced. See, you have to use your brains here. This part of the equation is balanced, this part of the equation is balanced, and this part of the equation is balanced, which means that I can only now manipulate either this or I can manipulate this. Now obviously this, I don't, in this particular case, the CXHY case, I don't know how many carbons I have, how many hydrogens I have, but if you go on to the left hand side, I know for a fact that on the left hand side you have, hydrogens and oxygens here, and the hydrogens, I can't balance out the hydrogens of water on the left hand side because I don't know how many hydrogens are present in the CXHY, so I can't play around with hydrogens, but I can play around with oxygens. Do you know why? Because on the right hand side you only have 8 oxygen atoms, 8 O's. I only see 4 times 2, I only have 8 O's on the right hand side. And if I have 8 O's on the right hand side, I must also have 8 O's on the left hand side. And how many O's do you already have on the left hand side? 4. See, 4 times 1, you have 4 O's on the left hand side already present. So what should I do with this O? What should I do with H2O here? See, you have 1 O in H2O and you need a total of 8, out of which 4 are already present. So how many more do you need? You need 4 more. So what should you multiply oxygen with? See, you have 1 oxygen. So what should you multiply 1 with to get 4 more? It's X equals 4. Right, so I'm going to insert a 4 here, and that is what makes all these 4 guys balanced. And now you can balance out carbons and hydrogen. See, you have 3 carbons on the left, and how many carbons do you have on the right? X. You don't know how many carbons they are. Now you know these are 3, because everything else is balanced. So if you have 3 carbons on the left, 3 on the right, and how many hydrogens do you need to balance right now? See, 4 hydrogens on the left plus 4 times 2, 8. So 4 plus 8, that's 12 hydrogens. 12 hydrogens on the left hand side, and you have 12 hydrogens on the right hand side. So the CXHY that you have is C3H12. Now there's no such thing as C3H12. Yes, you all know there's no such thing as C3H12, because if you think of a hydrocarbon, it can either be an alkane or an alkene, and the maximum number of hydrogens for a particular hydrocarbon is however number of carbons there are, hydrogens must be twice the number of that plus 2. So if you have 1 carbon, you must have a maximum of 4 carbon. You can't have more than 4 carbons for 1 carbon. If you have 2 carbons, the maximum number of hydrogens that you can have is what? 2 times 2 is 4, 4 plus 2 is what? 6. So you can have ethane, that's the maximum number of hydrogens. If it's C3H what? If you have 3 carbons for an alkane, how many hydrogens could you have? For 3 carbons, you can have a maximum of only 8 hydrogens. So that's the problem. There's no such thing as C3H12, is there? But now when you think about it, C3H12 is effectively giving you a ratio, that the ratio of carbons and hydrogens is what? It's 3:12. It's not actually C3H12, it's the ratio that you've calculated, which is the ratio of carbons to hydrogens is 3:12. And if you further simplify this, divide these both by 3, you get what? 1:4. What that means is for every 1 carbon, you have 4 hydrogens, and effectively you had methane. So sir, if you had methane, then why did you have C3H12 as the formula? C3H12 was just a ratio that you calculated through balancing the equation. And if I realize that CH4 is the hydrocarbon that I have, that means that you have 3 of those fella. See, if you write 3 moles of CH4 here, it's 3 times 1. You have 3 carbons, 3 times 4. You have 12 carbons. So effectively, you had 3 moles of CH4 actually forming on the right hand side. This is just reverse working, and it's a piece of cake. If you think about it, you didn't even have to look at the options. And if you check your options out, the options that makes the most sense is A, because it's only in A where you have 3:12 being fulfilled, because if you simplify 3:12, you get 1:4, and that is effectively CH4, right? So that's the idea. And how many moles of CH4 did you have? It's 3 moles of CH4 that I have. But the examiner has not asked you how many moles you need to have. It's just, it's just the final answer that he's required. KR, what was the fella? Sir, why don't you conduct marathons on YouTube? Techno, this is further uploaded onto YouTube. Sir, please, when will you do a separate marathon for inorganic and physical chem? I don't know, kiddo. At this point, I don't know. I'm so tired nowadays that I don't know if I'll have the time to conduct a marathon for this, because I am now focusing more on practice. I've already covered all the lectures with my students. So if you are actually interested, you can contact Ms. Naiba later on. She will accommodate you, inshallah. Question number 6, Sereno, the 2023 says, which compound has an MR of 84 and will react with HBr to give a product, one product, to give a product with an MR of 164.9. Now remember, HBr ke saath kya react karega out of all these compounds? See, this is a cycloalkane. Cycloalkanes don't react with HBr's, do they? It's an alkene. Alkenes don't react with HBr. You have alkenes reacting with HBr. So you realize that B will be able to react with HBr and D will be able to react with HBr because they effectively have the carbon-carbon double bond and they are alkenes. An addition reaction will take place, right? But if you look at C, C is a ketone, right? It's the carbonyl-carbon and it's followed by two alkyl groups. And ketones, we have not studied any reaction for a particular ketone in which a ketone or a carbonyl compound reacts with HBr. We've only studied one reaction of these carbonyl compounds, which is effectively the nucleophilic addition reaction with cyanide ions, haven't we? So C is effectively also incorrect. Then you have to look at B and D. Now, which of these fellas have an MR of 84? Let's check it out. You have one carbon here, 2, 3, 4, 5, 6, 7. You have 7 carbons with B, don't you? And B has 7 carbons, and so if it's an alkene, there's only one carbon-carbon double bond, and so alkene means it should fit the general formula of CnH2n. So if you have 7 carbons, hydrogen should be twice the number of that, that's 14. And if you check out the MR for this fella, is it equal to 84? 7 times 12? That's about something. And then 1 times 14. Does this equal to 84? This fella, I think, exceeds 84 if I'm not wrong. What does it give you? 7 times 10 is 70, 77, 84, 84 plus 14. That gives me what? That gives me what? 84 plus 14, 98. So that gives me 98. Then B is also wrong. And if you check D out, D is in fact the correct option. Why is D in fact the correct option? Because realize that even if I don't do anything, just through elimination, I realize that D is the correct option, but you can even prove it for yourself. See, 1, 2, 3, 4, 5, 6, 6 carbons. It's an alkene. C6H12 should be the molecular formula for it. And what should be the MR? 6 times 12. That's for carbon plus 1 times 12. What does that give me? 84. See, it fits 84, and when it reacts with HBr, one of the hydrogen would bond here and the Br would bond here. So effectively you now have what? C6H13Br, don't you? C6H13Br. And if you calculate the molecular formula for it, the MR for it, it should fit 164.9. Yeah, you can absolutely do that. Done, sir. So D is in fact the correct option, should be. B-carotene is responsible for the orange color of carrots. Such a beautiful molecule. Wow, I love this. I think B-carotene is oxidized by hot concentrated acidified aqueous potassium manganate. Now, you know, this fella actually results in oxidative cleavage. What that means is this fella ruptures the carbon-carbon double bond. The carbon double bond must rupture now, right? So what it's going to do is wherever you have the carbon-carbon double bond, these fellas are going to rupture. This fella is going to rupture, that fella is going to rupture, 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 rupture. Yeah. Now I think when an individual molecule of B-carotene is oxidized in this way, how many product molecules are formed? How many product molecules are formed? And then he says, many product molecules are formed. How many of these product molecules contain ketone functional group? So the products that are gonna form, how many of these fellas are gonna give you guys the key? How many of these molecules will have, how many of these product molecules, the individual molecules will have ketone functional group? See, the question is not asking you how many ketone functional groups are you gonna have. No. He's saying how many products would have ketone functional groups. It can have 1 ketone functional group, 2 ketone functional group, 3 ketones functional group. It doesn't really matter. But he's saying how many of these products will have ketone functional group. Now, if I recall your idea of hot acidified aqueous potassium manganate, which ruptures the carbon-carbon double bond, you realize that it depends. When will a ketone form? It depends. If you have carbon being bonded to 2 hydrogens when the double bond ruptures, this fella is going to oxidize into carbon dioxide and water. How will you do that? Not a part of my course and not my concern, effectively speaking. I've already covered every step of this in the live classes. Now, if it's bonded to a hydrogen and it's bonded to an alkyl, what happens is the double bond ruptures. What you get is you get an oxygen with the carbon double bonded to, you get the oxygen with carbon double bond, and then this H is present, the alkyl group is present right here, and the H is present. You get an aldehyde first, and the aldehyde also gets an O, so you end up with carboxylic acid effectively. So that's what you have if you have a carbon being bonded to an alkyl and a hydrogen. But you have a carbon in the double bond being bonded to two alkyl groups. Effectively, what happens when the double bond ruptures? This is, half of the fella that I've drawn. So when the double bond ruptures, you end up with a ketone. The carbon gains the oxygen, and you end up with a ketone, right? So this is what we are effectively looking for. This is what we are looking for, right? So carbon should be bonded to two alkyl groups in these case scenarios. Now, if you check the first carbon-carbon double bond, when you rupture this fella, see, this is the carbon, and this carbon is effectively bonded to, see, it's bonded to one alkyl group, is bonded to the other alkyl group. Check this out. This carbon is bonded to an alkyl group here. There's no hydrogen being bonded. Alkyl group, alkyl group. Even this carbon is bonded to alkyl group, alkyl group. Now, what students are doing is what they thought in this particular MCQ. I also got this MCQ from a particular student. They say, sir, when this carbon-carbon double bond ruptures, you're going to get one ketone here and one ketone here. Effectively, what they were thinking was, they were thinking that, sir, and please have this confusion crystal clear in your brain. They were thinking, sir, when this double bond ruptures, effectively, you're going to get C double bonded to O here, and you're going to get C double bonded to O here, effectively, right? And this is effectively my CH3, and this is a CH3 and a CH3. You have CH3 and CH3, right? This is the fella that you're getting. And students, what they did was they said, this is one ketone and this is the other ketone functional group. So effectively you have two ketone functional groups. But this is the incorrect way of thinking, because see, the examiner is not asking you how many ketone functional groups are you going to have. No. He's saying how many double bonds, how many molecules are you going to have, how many product molecules are you going to have which are going to have the ketone functional group. He's not asking you about the number of ketone functional groups. He's asking you about the product molecule. कितने products ऐसे बनेंगे जिसमें you have a ketone. Now you look into this question and tell me, should I consider this entire fella as one or should I consider it as two? Because see, effectively there are two ketone functional groups here, but you tell me, should I consider this one number? Like, should I give this only one number or should I give this two? These are two fellas. This is effectively one product molecule which has two ketone functional groups. So he's not asking us about the number of ketone functional groups. He's just saying how many products will form with ketone. So obviously I'm going to give this one number. This is one fella which forms here. And then you start to realize that, hey, this carbon right here, it does not have both alkyl groups in the double bond. It has one alkyl here and it only has one hydrogen. See, because it's bonded to, it's made three bonds. So the hidden bond is obviously with hydrogen. Hidden bond is with hydrogen. And if you look at this carbon right here, only this carbon, this fella right here, this carbon is bonded to an alkyl group here and it's bonded to the entire alkyl group here. So this fella, when it ruptures, this will get the O. This fella will make the ketone fella. So you realize that, okay, now I can actually see a trend. I can see a trend. Let's see, this will be this will give you a ketone product. This will give you a ketone product. I don't even have to look at all the others because this fella also has a hydrogen. So hydrogen and alkyl, this will give you carboxylic acid. Hydrogen and alkyl, this will give you carboxylic acid. The fella which is bonded to two alkyls will give you the ketone. So ketone here, and wherever you see now CH3, see, you've seen a trend here now. This will be the ketone. This will give you the ketone. What else? When this fella breaks, see, when this fella breaks, again, even this carbon, it's bonded to an alkyl group here, alkyl group here. This carbon bonded to an alkyl group here, alkyl group here. You'll have two ketone functional groups, but the molecule is the same, because once this breaks, you're going to end up with something that looks like this. The structure, the cyclic fella tends to open up. You know, with hot acidified potassium manganate, the cyclic structure starts to open up. This is the R, right? I'm showing when I'm breaking the carbon double bonded to carbon. For this carbon, I'm showing this entire part as an R fella. So this is the R that I'm showing, right? And then here you have two CH3s effectively. But the product is one. Remember, the product is one. Although you have two functional groups of ketone present here, two ketones, but the product in itself is one. So I'll consider this as one as well. So how many products do you get? 1, 2, 3, 4, 5, and 6. So I have 6 products with a ketone functional group. Even though 2 of these products have 2 ketone and 2 ketone, but I'm not going to consider this because he's not asking about the number of ketone functional. What if the examiner had asked how many number of ketone functional groups will form? Then the answer would have been 1, 2, and then 3, 4, 5, 6, 7, 8. Then the answer would have been 8. And see, to not confuse you, the examiner has not even given you the option of 8. So you only take into account the number of products with ketones, and that is what? 6. 1, 2, 3, 4, 5, 6. So B should be the correct option. Yeah, dots, isomerism, I've covered in my live classes in a lot of detail because that's the lengthiest part of organic chemistry. Nobody spends a lot of time on it. I've spent 20 lectures on it. So I can't cover isomerism in one marathon. I can make you rote learn isomerism in a marathon if you want. And if I'm going to do that, it's going to be towards the end of the, towards when the exams are right around the corner. Because isomerism is something so beautiful and it's like a puzzle. And I know there's no teacher in the market who teaches it like a puzzle. I've taught my students, जो मेरे students हैं उनसे पूछिएगा, if they have made notes for it, they can give you notes, but it's something that you can only understand if you take my lectures properly, because it's spread out over 15-20 lectures. Dot. So are you willing to give it 15-20 lectures? I don't think so. Any teachers is willing to do that. Only I was the only fella who gave it those lectures, because now everybody can name everything correctly. They can know how many isomers there are possible. But that's the most tricky part of organic chemistry. That's isomerism, because it's never taught properly. Could I send the lectures? You can contact Miss Naiba if you want to take the lectures, kiddo. +92 318 177 2015. That's Miss Naiba's contact. Mhm. You can take a screenshot here. Somebody can send it in the chat if they want. Yeah, you can have access to the portal then. Next question. 1,1-dichloropropane reacts with aqueous sodium hydroxide. What is 1,1-dichloropropane? First make propane, metheth pro. 1,1-dichloropropane means it's on the first carbon. So Cl on the first carbon, Cl on the first carbon. This is 1,1-dichloropropane. Great. I think it reacts with sodium hydroxide, but it's aqueous. See, now this is a haloalkane. Dichloropropane is what? It's a haloalkane. And haloalkanes, when they react with aqueous sodium hydroxide, if you've watched the marathons, what happens? When sodium hydroxide is ethanolic, we know that the hydroxide ion behaves as a base. And when it behaves as a base, it accepts the proton and an elimination reaction takes place, isn't it? But when it's aqueous, the hydroxide ions behave as a nucleophile and a nucleophilic substitution reaction takes place and you end up with alcohol. So effectively, you're going to end up with what? You're going to end up with alcohols. Done. Now he's saying this reacts and in a series of steps to give propanol. So what effectively happens, see, a series of steps. Now that you've studied organic synthesis from me, I've taught you guys effectively 4-hour and 3-hour, effectively 7 hours course of entire mechanisms, all the summary of organic chemistry I've given. If you've not taken it, watch my YouTube lectures. 2 marathons are available at Carboxyl Camp. You will be able to solve all of these. You'll be able to think like me. So see, he's saying it's through a series of steps. Now, sodium hydroxide aqueous, when you react it with a haloalkane, it actually gives you an alcohol. But if you want to end up with aldehyde, what do? How do you go from alcohol to aldehyde? A primary alcohol goes into an aldehyde if you use what? K2Cr2O7, acidified aqueous potassium magnate. But remember, you heat and distill it, because if you don't distill it and you heat under reflux, you know that the aldehyde can further convert into carboxylic acid. So that's how you're going to end up with aldehydes. Great. He isn't concerned about this. This is not what the MCQ is about. The way I like to teach is I want to explain all the concepts through a particular statement, even although it may not be the relevant question here. See, the question is not this. The question is, what term describes the first step? So the first step is obviously nucleophilic substitution, wherein you go into the alcohol, and the second step is obviously oxidation. So he's talking about the first step. What's the first step? Because tomorrow in the exam, because questions aren't repeated, so tomorrow in the exam they can even ask you what's the second step. So the second step is oxidation. The first step is what? Nucleophilic substitution. It's not addition, not elimination. Elimination would have been there if it was sodium hydroxide ethanolic. Then an alkene would form. Oxidation is the second step. It's not addition because nothing is being added. The Cl2s are being substituted. See, there are no Cl2s on the right-hand side, and it's substitution. And if you were to make it more accurate, it's effectively nucleophilic substitution, because the reaction is initiated by a nucleophile. Asan? You guys, I don't know why you guys think organic chemistry's MCQs are difficult. MCQs are the easiest, not just organic chemistry. A-level chemistry MCQs are very, very easy, as long as they're difficult if your concepts aren't clear. They're the easiest as long as your concepts are clear. Yes, sometime here and there you might as a student face a single MCQ which you may not be able to comprehend, but generally speaking, when you do these MCQs, it's a piece of cake. It should be a piece of cake for everybody, at least my students, but obviously for students who studied from elsewhere and their concepts are clear, it should be a piece of cake for you guys as well. Yeah. तेरी यादें वो सारी बातें तू ही बता. So the issue is that there's too much content for organic chemistry and I end up forgetting one or two things. Dot for this, the best way is to practice first of all. The second best way is to take my marathon classes and the mind maps that I've made. The mind maps that I've made in my marathon classes, they are so coherent that it will always help you out. Daniel is saying I will send you the footnotes. I think Daniel, are you part of my class? I think you are. I don't know. I think Danny koi tha. I think Danny was there. If not, even if you have note shoots to put. Acha, one more recommendation that I am going to give you as a teacher. You haven't, unfortunately. Chalo, it's okay. It's okay. At least you're taking my classes now. One more recommendation that I want to give you guys as a teacher is the fact that in A levels, a lot of students, they start to grasp at straws. They start to try to grasp at straws. They start to read notes from left, right, and center. Please, it's my utmost, like the biggest suggestion that I have, at least for my students, is to not stick to any notes. Read the notes that you've made from my lectures. Read your own notes, because in A levels a lot of teachers are not well versed with the syllabus. They tell you guys, in A levels you'll see a lot of teachers will be in disagreement over certain concepts. Because why? Cambridge teaches it a certain way, maybe metric teachers teach it a certain way, another teacher teaches a certain way. So please, this is my request to each and every one of you, to stick to your own notes. That's the first request. The second request that I have is that if you have not made your own notes, then stick to one person notes. If you've not made notes on your own and you've not written anything throughout your A-level career at this point in time as a student, if you've not written a single note, or if your notes are pathetic, you've not organized them, if you've not written them in a coherent manner so that you can revise them later on, then take notes. But see, if you start taking notes from my student, from another person's students, from another, you will be overwhelmed with the amount of information. Just like a student said, there's so many things that I can't grasp or I can't comprehend. That's why I always recommend, it's still time, you can still do it, but just stick to one thing. Sir, watched your organic chemistry marathons a few hours before my mocks today. It went really well. I'm glad, Mariam. Thank you very much. I'm glad. It's all hats off to you guys for putting in the effort, right? आपकी मेहनत है अपनी, मैं तो कुछ नहीं करता. I'm just a mere guide. Propanoic acid can be made from bromoethane using a two-stage synthesis. Now, देखिए, even though the options are given to me, but because I've taught you guys organic synthesis in a very, very beautiful manner, I've connected everything through mind maps, you can actually think about it. So he's saying propanoic acid, it's effectively what? It's a carboxylic acid. And he's saying it's made from bromoethane. Bromoethane is a haloalkane. Now start to think about haloalkanes and their reactions. See, it's a two-stage synthesis. So how can you effectively go from haloalkane into carboxylic acid? Can you go from haloalkane directly into carboxylic acid? The answer is no. You must have another step in between. Now, haloalkanes, see, I want you guys to start using your brain. Haloalkanes can directly go into carboxylic acids. You've studied no such reaction in which haloalkanes directly go into carboxylic acids. I know I can go over the MCQ options with you, but I want to first pick your brain a little, right? So, sir, I use mine and Fatma's notes, by the way. Can you ask her to share organic chem notes if she wants? Fatma's notes are OGR. Uske notes, she's made such beautiful notes and she will send it, but unfortunately, what's this student's name? Marcia, and the unfortunate thing is Fatma is going to appear in October, November. That's the problem. So the notes that Fatma is making, she's going with a very, so I think she has only made notes till redox. You're also appearing, so she has not yet made notes of organic chemistry. She's promised me that once she makes it, she will send me the notes and then I'll add the carboxyl logo to it. She has promised me this. So inshallah, once she makes it, so then we will add the logo of carboxyl to it as well. And then students can use those notes. And such beautiful writing. She has such, it looks like it's written with the help of a printer or something. So haloalkanes can go into carboxyl. Now think of the reactions of haloalkanes. Haloalkanes can undergo nucleophilic substitution reactions and they can go into alcohols. And primary haloalkanes will go into primary alcohols, which can go into carboxylic acid. So this is one step of the mechanism, right? The other step is that haloalkanes, they can go into nitriles by reacting it with cyanides, by reacting it with NaCN, ethanolic, and heat under reflux. You're going to go into cyanide and nitriles, and then the nitriles, when you add dilute acid to it and heat, dilute hydrochloric acid or sulfuric acid, whichever one you use, and heat, you basically acidify. This is hydrolysis. Yes, so carboxylic acid can form even then, and this is effectively nucleophilic substitution reaction. Primary alcohol is nucleophilic substitution reaction, and this fella, primary alcohol to carboxylic acid, that's what? That's oxidation. That's also one way. The other way is also to take a haloalkane and convert it into an alkene through the elimination reaction, and that's going to require sodium hydroxide ethanolic, by the way, because we want the hydroxide ion to behave as a base. And once an alkene forms, you can use hot acidified aqueous potassium, hot concentrated acidified aqueous potassium magnate, KMnO4. Yes. And only if the carbon has an alkyl group and a hydrogen group in the alkene, right here, if it's and the alkene that forms has a carbon bonded to an alkyl and a hydrogen, only this will first go into an aldehyde and then quickly convert into a carboxylic acid. Remember, an aldehyde does not form as a complete product when in hot acidified aqueous potassium magnate. The moment it forms, it converts into a carboxylic acid, right? You get an O here with this hydrogen and you get an O here right now. So this is the idea behind it. These are the three ways in you can the three two-stage synthesis in which you can go into carboxylic acids using what? Haloalkenes. Other than this, you've not studied anything, right? These are the three ways in which you can use. Now, which of these three ways are we going to use? Just suppose you had no options available. Please, I want to train your guys. I want to train your guys' brains. I want you guys to think, not just to look at the MCQs. You can look at the MCQs and think on your own. Later on. You can do it. So it can probably help more if you've taken sales lectures, but if you can understand the mind map without the negative. Yes, absolutely, guys. Absolutely, Havanya is absolutely right. Sir, do you know a good online teacher to help us solve biotopicals and yearlies? I don't effectively. Sir, Dawood is my brother. He's pursuing a PhD at Imperial College London, but he's doing topicals and वो बड़े आराम आराम से कर रहे हैं. तो उनसे पूछिएगा, मितनाइबा से पूछिए. जाहिर सी बात है, उनसे तो बेहतर कोई नहीं होगा. But खैर, that's the idea. Now, I think which pair is more suitable? If you look at the question now, look at the question. Forget about the options. Look at the questions. Bromoethane. Bromoethane. Ethane means you have a two carbon haloalkene. And here, propanoic acid is a three carbon carboxylic acid. Yes, he's studying from Imperial College London. He did his undergrad, masters, and now PhD is a joint PhD from Imperial and Caltech. Yeah. I also got into Imperial College London, but I ended up pursuing chartered accountancy, by the way. So maybe you threw. How do you contact her? Contact Miss Naiba. If you contact Miss Naiba, she will get you because दाऊद इज़ माय ब्रदर. तो सर दाऊद मेरे भाई हैं, तो वो हमारी एकेडमी में ही हैं, मेरी एकेडमी में और उसकी एकेडमी, दोनों की एक ही चीज़ है यार. मैं वो दोनों शौक से करते हैं. खैर, this is the only time he's teaching, by the way. After this, he was like, Sulaiman, I'm not teaching anymore. I'm done with this shit. I was like, okay, relax. It's up to you, man. It's like, it's up to you. Acha, so which of these options should we look into? Now, if it's a two carbon haloalkane going into a three carbon carboxylic acid, which idea clicks in your brain? The idea of nitriles should click in your brain because you realize that the reason why we go into nitriles is because it increases the number of carbon by one. So you went from two carbons to three. That means you must have gone into a nitrile first and then into a carboxylic acid. And that means what? That means that you've not used hydrogen cyanide, because in order to go from a haloalkane into a nitrile, you have to use sodium cyanide ethanolic. So aqueous sodium hydroxide, no, that's not what gives you nitrile. Ethanolic sodium hydroxide, no, that's the elimination reaction. Potassium cyanide, yes, potassium cyanide. And then see, later on he's using dilute hydrochloric acid and he ends up with a carboxylic acid. See, this is the beauty of chemistry. It's so connected. It's like a puzzle. It's like a puzzle. Sir, show me the working. Here you go. मजा आ रहा है guys आपको? Are you guys enjoying? क्या बात है sir, unity. Sir, if you remember, it is like a puzzle. It is. Absolutely. See, Vanya is so quick with it. Boom, boom, boom. Boom, 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 boom. Organic कौन enjoy करता है? Techno students who studied from me, they enjoy organic. Or who study from any teacher and they've studied with passion, और teacher ने शायद गलत बलत भी पढ़ाया हो, लेकिन वो शुगल से पढ़ा हो, अच्छे खुश होके पढ़ा हो, तो everybody enjoys. Hmm? Boom, boom, soup. I'm gonna bring water, guys. I'm tired now. Wait, I'm gonna get some water. Mhm. Soup noodles, तुझसे मजा कौन चाहे भूख भूख. Done, guys. Next, Jan. Sir, how do you know that these options are correct? I know it because my concepts are clear. If you ever see the paper is written here, so if you ever contradict with my concepts, you guys can check out the options even by checking out the year and blah blah blah. Check करें. If you guys think an option is wrong, do let me know later on. But inshallah, they won't be wrong. Na? बस ना क्यों गलत होंगे? If your concepts, if I'm thinking in the right order, why would they be wrong? Question 10. Structural isomerism and stereoisomerism should be considered when answering this question. Okay, I will consider them. So structural and stereo. And remember, stereoisomerism mein kya? Also consists stereoisomerism consists of optical isomerism in which you have a chiral carbon. And what's a chiral carbon? In which a carbon is bonded to four different groups, four groups or four atoms, different groups or different atoms, right? And stereoisomerism can also be geometric isomerism. And geometrical isomerism kya hota hai? In which each of the carbon in the double bond is bonded to two different groups, A and B. This is A and B. They can be on the same side, on opposite sides, and that is what would result in geometrical isomerism or cis-trans isomerism. And groups or atoms, same thing. Sir, when are you starting yearlies? I don't know when. Sir, and it is necessary for all our topical course to be covered before it? No. ईयरलीज में मैं करूँगा टॉपिकल्स लेकिन 2025 की ईयरलीज करूँगा इफ आई वर टू स्टार्ट बिकॉज आई थिंक दैट इज मोर इफेक्टिव फॉर स्टूडेंट्स सर नॉट गोना लाई ऑर्गेनिक डिडंट लाइक इट इन ओ लेवल बट in A levels after taking your lectures everything works like a puzzle. I'm glad, Vanya. I'm glad, Vanya. I'm happy for you. Okay, डन करें. हाँ मुझे मैसेजेस क्यों आ रहे होते हैं? शान शुप नूडल्स तुझसे मता कौन चाहे बुक बुक. अच्छा स्टार्ट करेंगे आगे बढ़ें. 10 MCQ के बाद 10 मिनट की ब्रेक लेंगे फिर हम आगे बढ़ेंगे. सॉरी गाइस फॉर वेस्टिंग योर टाइम. A set of isomeric hydrocarbons form. Okay, hydrocarbons are compound. देखिए, this is how I think of when I'm solving MCQs or theory. I read every single word in a lot of detail. Hydrocarbons, okay, should click in my carbon and hydrogen atoms only. Okay, it contains 14.3% by mass of hydrogen. So see, because I read this word properly and I did not skip through it like a lot of students would, I read it very carefully that it's a hydrocarbon. And when he gave me the percentage, this much percentage by mass is hydrogen, I automatically understood, okay, if you have a hydrocarbon, it must have hydrogen and carbon only. And if the percentage is 14.3% is hydrogen, what is the percentage of carbon? 100 minus 14.3. What do you get? 100 minus 14.3. Somebody? 85.7. Okay. 85.7. And so now that you have the percentages, you can actually even calculate the empirical formula for it, which is the simplest whole number ratio. So divide this by the AR, divide this by the AR, what do you get? Or the molar mass, what do you get, guys? You get what? 14.3 and 7.14. Okay. And then you divide with the simplest ratio here. So 7.14, 7.14. And so it's 1:2. Effectively, for one carbon, you have to have two hydrogens. It's basically for one carbon, you have to have two hydrogens. Asha, if for one carbon, you have two hydrogens, for two carbons, this is just my question from you guys. If for one carbon, you have two hydrogens, for two carbons, how many hydrogens would you have? If the empirical formula is CH2, that means if I were to now start to think about the molecular formula, if you have for one carbon, you have two hydrogens, for two, you would have four, for three, you would have six, for four, you would have eight, and so on and so forth. And what does this indicate? This indicates that the fella that you're talking about would be effectively an alkene. So see, if it's a hydrocarbon, it can either be an alkene or it can be an alkene. And so when I looked at CH2, I realized that for one carbon, you have two hydrogens, and that fits the general formula of CnH2n. This is how you calculate empirical formulas. You used to do this back in O level and IGCSE, didn't you, Danielle? You know? we did not divide it by the MR, we divided it by the ARs or the molar masses. Because whenever you used to be given percentages in O-level IGCSE chemistry or even in A-level modes and organic chemistry, you used to do what? You used to figure out the empirical formula through it. The mass spectrometer gives you the frequency or the abundance of all of these things. And then what do? You can calculate the empirical formula, and then from the empirical formula and using the molecular mass of the entire compound, you can actually calculate the molecular formula. Yeah, divide by the AR, then divide by the simplest ratio, and then you get the empirical formula. Remember this? If you don't, then you have to watch O-level IGCSE moles video wherein I have discussed empirical formula, or in A-levels I've also explained it in moles and stoichiometry, so you can do that. So this is effectively an alkene, right? It must be an alkene. Now which alkene is it? That's the next question. Which alkene is it? Now let's read the question more and see. It says all of this hydrocarbon would react with bromine by addition reaction. What does this tell you? Which particular fella reacts with bromine through an addition reaction? हाँ जी बताएं. Even if you had not used this much brain, इतना दिमाग आप खोपड़ी नहीं इस्तेमाल करते, तो it was okay, because even here he's telling you that it's what? It's gonna be an alkene. My mass spectrometry video is available on YouTube. I think it is. If you're talking about analytical side of it, the one that is linked with organic chemistry, in which you have peaks, that is available. It's like a 40-50 minute video. I've explained all of the things in that in a 40-50 minute video, and after this I will do questions from analytical chemistry, inshallah. So bromine by addition, he's even explained it to you that and you know that the only fella which would react with bromine by an addition reaction is effectively an alkene. So this further reiterates the fact that it's an alkene. Good thinking. Then it says, okay, if it says that it will react with bromine, that means I can simply say that bromine, now I don't know the alkene, do I? At this point, I don't know the alkene. I can say it's a CXH2N fella or CNH2N fella, right? Because I don't know how many carbons there are in this alkene, and I don't know how many hydrogens there are, but I know it's an alkene, therefore it should fit the general formula of CnH2n. That's the idea. Achha, I'll see to it. Let me check if it's not available. I'll try to upload it then. Achha, now my question to you guys is, when a bromine reacts with any alkene for that matter, if it reacts with C3H6, if Br2 were to react with C3H6, C2H4, Br2 were to react with it, what do you end up getting? When addition reaction takes place, what do you end up getting? You end up getting a haloalkane, and you're going to end up getting C3H6Br2 here, C2H4Br2 here. So effectively what you realize is, for 1 mole of alkene, you just need 1 mole of Br2. 1 mole of the double bond, you need 1 mole of Br2. So I can safely derive this relation that for 1 mole of Br2 being added, you just need 1 mole of alkene, don't I? I've even proven it to you, right? So for 1 mole of this fella, you need 1 mole of bromine. Now, what is he saying next? He's saying that 0.280 grams of each hydrocarbon reacts with 0.799 grams of bromine. Now, he's saying that you have these many grams of hydrocarbon and you have these many grams of bromine. Now, as a teacher, I know what to do, but as a student, you might not know what to do with this information. Let me tell you what you can do with this information. See, you need to add Br2, and for Br2, you can readily figure out the MR, or if you want to call it the molar mass, like I've taught you. How can you calculate the MR or the molar mass of Br2? Through the periodic table, can't you? And once you have the MR or the molar mass of bromine, you also have the mass of bromine. By using the mass of bromine and the MR of bromine from the periodic table, or the molar mass of bromine, what can you figure out? You can figure out the moles of Br2, and then from the moles of Br2 you can actually use this relationship to figure out the moles of alkene. And once you have the moles of this alkene, you can use the moles of this alkene and the mass of this alkene to figure out the MR of this alkene, can't you? This is the thought process. Now, those of you who might have thought, sir, I'm given the mass of this hydrocarbon, can I not convert this into moles? Can you not convert the mass of the hydrocarbon into moles initially? No, you can't. Do you know why? Because you don't have the molar mass. You don't have the MR of this hydrocarbon. You don't. It's N and it's CnH2n. You don't know what the hell the hydrocarbon is. How would you end up with the molar mass or the MR for it? And how would you then convert it into moles? So you need to take help from bromine. As a student, this is how you should start to think, right? So bromine se main ab kya karunga? What is the molar mass of bromine, sir? from the periodic table. Either tell me the molar mass MR, it's the same thing, right? It's better to use the word molar mass. Those who have not studied moles from me, they don't know the difference, but it's better to use the word molar mass. So what am I going to say? And say, hey, mass equals mole times molar mass. The mass of bromine is given to me, which is what? 0.799 moles of bromine. I need to figure out what's the molar mass of bromine. Somebody tell me what is bromine, please. What is bromine? 81 point क्या आता है? Bromine is what? 81 point what? Somebody please help me out. Look into your periodic table. Group 7. Please, I don't have anything in front of me. Please help me out, guys. Help me out, somebody. यार कर दे यार, कोई बता दे यार, किसी के पास पीरियोडिक टेबल नहीं होता. 79.9 श्योर. So 79.9 into 2. So n equals 0.799 divided by 79.9 into 2 क्या आता है? Yes, 159.8. What does this give me? How many moles do I get, guys? 5 into 10 raised to power minus 3. Thank you. So these are the moles of bromine. And if you have the moles of bromine, it's 1:1. So how many moles of the hydrocarbon are you going to have? N equals the same. It's 1:1. So you're going to cross multiply, or what you could do is use basic common sense that it's going to be the same number of moles. And now that you have the moles of hydrocarbon, what do? You use the moles and the mass of the hydrocarbon to figure out the molar mass. Mass equal moles times molar mass, or the MR, right? So mass कितना है? MR कह दे, molar mass कह दे, it's the same thing. But it's better to use the word molar mass. Mass कितना है? It's given in the question, which is 0.280 moles of the hydrocarbon. You figure out MR or molar mass. You have to figure out what's the MR or molar mass. 0.280 divided by 5 into 10 raised to the power minus 3. What do you get MR as? 56. Now MR is 56 for this fella. And you know that the empirical formula CH2 was the empirical formula, and then you realized it was an alkene and blah, blah, blah. So now you have to just do trial and error. You have to do trial and error. Okay, which of these fella has an MR of 56? So you start doing trial and error. C2H4 has an MR of, I don't know. It's not 56, by the way. 12 times 2 plus 1 times 4 is about 28. C3H8, 12 times 3, that's 36. Plus what? C3H8 करें. 36 plus 6, 1 times 6, that's 42. I think the next guy would be my answer. 12 times 4 plus 1 times 8, what does that give me? 48. 48 plus 8 is 56 right here, guys. Here you go. So effectively the alkene that you guys had was C4H8. Do we have the options here? Acha, this is not the question. Now, what the hell? This is not the question. Now he's saying how many number of isomeric products are formed in this set. Now C4H8 is effectively what? An alkene as butene, right? Now you know butene can exist in the form of but2ene. It can exist in the form of but1ene, and it can also exist in the form of 2-methyl but1ene, right? So you can have one fella here, one fella here, and remember this, he said also consider cis-trans isomerism, consider geometric isomerism, stereoisomerism, and you know that this fella but2ene always exhibits cis-trans isomerism, because see, this is on the opposite sides. Look at this, the opposite side, hydrogen and alkyl here, each of the carbon in the double bond is bonded to two different groups. One is hydrogen and one is alkyl. One is hydrogen, one is alkyl. So you realize that, hey, this fella is the trans version of it, and this fella is the cis version for it. Cis but2ene, trans but2ene. So you realize this is one, that's one. So in total you have 4 isomers that can exist for it. And what the hell was the examiner thinking when he tested this MCQ? Such a beautiful MCQ. Such a beautiful MCQ. Loved it. Can somebody also check the marking scheme for it? I loved this MCQ, by the way. Sir, it is C. Sir, it would take forever to solve. It wouldn't take forever to solve. It takes forever to explain it in a good manner. I could have solved it very quickly. It would have taken me less than 45 seconds, and it would have taken you less than 45 seconds if this concept was clear. Now, if such a question were to be tested in the exam, you can do it in less than 45 seconds. You can easily do it in less than 45 seconds. I have to take my sweet time on it to explain every single step in a very crispy manner. मजा आया, enjoyed. What time does the marathon end? I don't know. फिर इंशाल्लाह it will come. ठीक है जनाब. अच्छा जी, next. I don't know when it'll end. I have to do the 2023 set completely. Acha. Which reagent can confirm the presence of a carbonyl group in an organic compound? Now remember, carbonyl group is basically talking about the C double bonded to O. And which reagent confirms this? You already know that's what? That's 2,4-DNPH. Dinitrophenyl hydrazine. So 10 questions ho gaye. It's good. See, it doesn't matter how many MCQs you do in A levels. What matters is the quality with which you do it. I'm doing it with quality. So I can do it very quickly if you want, but I want to do it with quality, right? Now, which reagent, number one, can confirm the presence of carbonyl group, that's 2,4-DNPH, and it does not distinguish between aldehydes and ketones. Yes, 2,4-DNPH does not distinguish between aldehyde and ketones. To distinguish between aldehydes and ketones, you use milder oxidizing agents like what? Like Tholen's reagent or Felling's solution or Benedict's solution. Felling's or Benedict's solution, don't you? Tholen's reagent gives you, it's also called a silver mirror test. It gives you a silver mirror as an observation with aldehyde because aldehyde is further oxidized. And Tholen's reagent is basically ammoniacal silver nitrate, right? So you use ammoniacal silver nitrate. It's dissolved in ammonia. And what happens is the silver ions basically, they oxidize the aldehyde and themselves get reduced by losing an electron. So by gaining an electron. So they themselves gets reduced by gaining an electron, and then they give you silver. And that is why you see a silver mirror. And Feding solution effectively are copper 2 plus ions involved, right? These are all complex ions. So they are involved and they have a blue color. And the moment they oxidize the aldehyde, ketones are not oxidized by these milder oxidizing agents, by Tholen's reagents, Fenning solution. So what happens is they have a blue color, and the moment Fenning solution oxidizes the aldehyde into carboxylic acid itself the copper 2 plus ion gets reduced into copper 1 plus ion, and the copper 1 plus ion ends up making a bond with the oxide ion present, and it gives you copper 2 oxide, copper 1 oxide, which is Cu2O, and this is a red precipitate effectively. So you have an observation which goes from a blue color to a red precipitate. You don't need to know this part of it, but it's a very, very basic idea. An oxidizing agent reduces itself to oxidize others. So itself, it gains an electron. That's why you end up with silver mirror. That's why teachers should teach you these things, right? Khair. Moving on. So it's 2,4-D in pH, isn't it? Acidified potassium dichromate will not confirm the presence of carbonyl group. You can actually use it to distinguish between aldehydes and ketones, but it's not recommended. A recommended bit is to use Tholen's reagent and Felling's solutions. You can do it, but again, it's not recommended. Felling's reagent, again, Felling's reagent नहीं कहते इसको, Felling's solution कहते हैं, by the way. Don't call it a reagent, call it a solution. But it's okay, same thing. It's going to distinguish between aldehyde and ketone. See, these things, which reagent will not distinguish between aldehyde and ketone? This fella will distinguish between aldehyde ketones, right? So realize that C is incorrect. LiAlH4, this is a reducing agent. This is a reducing agent. This is not an oxidizing agent. So मैं कह सकता हूँ, it's a reducing agent. It does not confirm the presence of carbonyl group. Done. So D is wrong. Next. मजा आ रहा है everybody? I hope everybody's also enjoying, because this is like an enjoyment session. Boom shakalaka boom. I'm crazy, guys. I'm a crazy man. I hope you all are enjoying. समझ आ रही है, अच्छी बात है डॉट. या इसका आंसर डी है. मुझे क्या पता इसका आंसर डी है या नहीं है. आई एम गोना डू इट राइट नाउ. आई एम नॉट अ जीनी, एम आई? Acha. Now, compound X is present, and he's saying two samples of compound X were treated separately with different reagents which are added in excess. The products of these two reactions are shown. Okay, reaction one ka hai, reaction two ka hai. Now, always whenever you're given such reagents and such products, always see the differences. This is how I tend to look at it. So if I look at this fella and the difference between this fella and this fella, see, you have an alcohol here, an alcohol here, a ketone here, a ketone here, an aldehyde here. You will see he's not shown an H, so this is effectively an aldehyde. You have an aldehyde here and you have a carboxylic acid here. So effectively you've taken an aldehyde and converted it into a carboxylic acid. And by the way, which alcohol is this? This is a secondary alcohol, isn't it? Because see, the carbon that the OH is bonded to two alkyl groups. So you have a secondary alcohol. Now, what you've done is the change is that you've gone from an aldehyde to you've gone from an aldehyde into a carboxylic acid, and that is what? That is oxidation. Now, which oxidizing agent which you have used? Obviously, you would have used a milder oxidizing agent. Either you would have used Toland's reagent, which is silver nitrate dissolved in ammonia, or you would have used Fehling solutions, which is effectively copper 2 plus ions. Either or. Now my question to you guys is, and this would have oxidation would have taken place and it would have all oxidized the aldehyde into carboxylic acid. My question to you guys is, could I have used K2Cr2O7 acidified K2Cr2O7 acidified aqueous, or could I have used potassium manganate acidified? These are also oxidizing agents, the two other oxidizings which are part of your course. Could I have used these two? think दिमाग पे जोर डालें, जोर डालें, जोर डालें, जोर. Do this. Could I have used them? Do this. Sir is crazy. Sir is crazy. I know sir is crazy. Hanji. Could I have used this? No, I couldn't have. Why? K2Cr2O7 potassium dichromate. Don't say I don't, I think no. No, I think no. Be confident. You know you couldn't have used this because these two fellas, although they would have converted the aldehyde into carboxylic acid, they would have also oxidized the secondary alcohol into a ketone. Now don't say I think. It's a very basic idea. And what you see is on the left hand side and on the right hand side, you both have secondary alcohol. So you couldn't have had these two. And probably he would have asked this in the questions, which reagents can be used for 1 and 2? So for reaction 1, can you use hot acidified sodium dichromate or potassium dichromate? No, because it would also oxidize the secondary alcohol. Toland's reagent followed by hydrochloric acid, and Toland's reagent followed by hydrochloric acid. Yes, absolutely. Do you know why? Because once you use Toland's reagent is effectively silver nitrate, and I've discussed this in the live class. It's effectively silver nitrate dissolved in ammonia. And when you use this, you don't end up with carboxylic acid directly, you end up with a salt of the carboxylic acid. And once you end up with the salt of the carboxylic acid, you further acidify this salt. This fella is further acidified, and you then get the carboxylic acid. You get the carboxylate salt. Done. So yes, C or D में अब option होगा. Now reaction 2 में देखें, what's the idea? In reaction 2 you have secondary alcohol here, you have ketone and aldehyde, again the same. And in reaction 2 you have the secondary alcohol as is. Ooh, say ooh, everybody say ooh. The ketone is now gone into secondary alcohol, which means the ketone has been reduced, so reduction would have taken place. Right? Reduction has taken place. Dot, you can watch the video later on. एक दोबारा फिर recording please. Yeah, end तक सबर करिए. So you have a secondary alcohol forming from a ketone, and so if a secondary alcohol forms from a ketone, that means the ketone has been reduced. And which reagents can you use to reduce ketones? You could use LiAlH4, you could use NaBH4, aqueous LiAlH4 in dry ether, you could use hydrogen and nickel and heat, you could use either of these three reagents, right? And see, even the aldehyde has converted into, the aldehyde is converted into primary alcohol. And you know, when you use reducing agents, you will go from ketone to secondary alcohol and aldehyde to primary alcohol. And you know all the reasons to that in the live class. I've taught it in the marathons, I've taught it, so you know this. So effectively you're using a reducing agent, and which reducing agents? You could use LiAlH4 in dry ether, you could use NaBH4 aqueous, you could use hydrogen and nickel solid and heat, either or, तीनों में से कोई भी, right? So what has he said? Reaction to me is saying sodium. Oh no, you dumbo mumbo. If you use sodium, the sodium is just going to react right here with the hydrogen of the alcohol and form, like, you know, ethoxide banayega. Ethoxide. Nobody cares about that woman in life class, because alcohols are slightly acidic in nature. Slightly acidic. They're not acid. They're slightly acidic in nature. You know, so they're gonna do the same metal displacement reaction. But yeah, and it's gonna form half a mole of hydrogen. That's all. I'm trying to cover everything through a particular MCQ, by the way. So this is wrong. And for D is the option. Maybe you did not need to write all this stuff. Maybe it would have taken you 5 seconds to solve it. But my job is not to solve it. My job is to revise your concepts. MCQ number 13. करें जी बढ़ते जाएं 13 में जाएं 13 में जाएं हम yes he's saying which method could produce butanoic acid. It's a 4 carbon carboxylic acid. I think an acid-base reaction involving meta, ether, proper, buta, and this is the salt of butanoic acid, right? So if you have the salt, the carboxylate salt, it's basically the butanoate salt. So if you have the butanoate, it says this is COO, right? It's C double bonded to O. This is minus, this is Na plus. And obviously, when you use dilute acid here, an acid-base reaction does take place, and you're gonna end up with carboxylic acid. So effectively, this fella would go into CH3, CH2, CH2, CO2H or COOH, and that's absolutely true. Butanoic acid would form. I've even discussed it in the marathon classes. A is in fact correct, but why is B, C, and D wrong? See, if you hydrolyze this fella, nitrile, it's meth, eth, pro, but, pent, it's pentane nitrile. When you hydrolyze it, instead of this N, you get COOH, right? So it becomes pentanoic acid. This is pentanoic acid, right? That's why B is wrong. If you look at C, the acidic hydrolysis of this. Now this is an ester. See, C double bonded to O. This is CH2, CH2, CH3. You have propyler. You have propyler. And which acid did you have? Mether, ether, prop. You had propyl, propanoate. So when you perform dilute, when you add dilute acid to it or dilute acid to it, what happens? The ester linkage breaks and you end up with what? A 3 carbon carboxylic acid, which is what? Meth prop. It's propanoic acid. He's saying you want to make butanoic acid. The oxidation of this meth eth propanol, propan 1-ol is oxidized into propanoic acid, not butanoic acid, is it? So D is also wrong. Sir, structural formula is difficult. Kiddo, I can only tell you to watch my videos in which I've discussed structural formulas, skeletal, isomers, all of that stuff. I can only recommend this because at this point I can't, explain to you what I've explained in 20 classes. It'll be unfair to me. Now, 20 classes means 20 hours. So I've spent about 20 hours teaching students formulas, isomers. तो मैं उसका मतलब कह I'm sorry, but I can't do anything about it at this point. कोई एक पर्टिकुलर पोर्शन अगर हो तो वो मैं ज़रूर एक्सप्लेन कर सकता हूँ, वो मुझे आप डीएम कीजिएगा। लेकिन अगर ऐसे हम कहें कि पूरा स्ट्रक्चरल फॉर्मूला समझने की कोशिश करें तो नहीं हो पाएगा ना अभी एट दिस पॉइंट, क्योंकि उसमें आपने खुद वो लेक्चर्स देखने होंगे। इट्स अ स्लोअर इटरेटिव प्रोसेस जिससे आप वो समझेंगे। नेक्स्ट क्वेश्चन। Should we do more questions or should I just call it a day? Yes. Let's take 5 minutes break. Mishal is saying more questions. Mishal, why aren't your friends here, huh? It effectively acts as a base. It effectively acts as a base. And the mechanism is been part of your course, Huma. That's why when I was talking about and see, even if you did not know this, you could have easily eliminated all the other options out, because yes, some students may not have known this, that the salt, if you acidify the salt, you can go into an acid base type of reaction. Maybe not a lot of you guys might have known this. I've actually taught it in my marathons. But even if you didn't know it, it's okay. In A level, sometimes you wouldn't know some terminologies maybe, but you have to look at every other option then. See, maybe if this confused you, you should have looked at other options. My friends are sleeping. Got it, Huma? Great, I'm glad. There is reason to it, Huma, though. But again, you just skip out on the reasons. Hmm? करें, चलो जी। नहीं, मुझे तो खुशी तब होती है कि जब 100 बच्चा बैठा होता है ना, फिर मज़ा बहुत आता है। And there are about 100 kids sitting in the class. अरे हाय हाय हाय, मज़ा ही मज़ा आता है। Bromine reacts with alkenes by an electrophilic addition mechanism in which a cation is formed as an intermediate. Which mixture? Acha. What am I? I'm just reading the English and I'm not even focusing. Okay, focus. Bromine reacts with alkenes, okay? Electrophilic addition reaction mechanisms take place in which a cation is formed as an intermediate. Which mixture will produce the most stable intermediate cation? We know that a tertiary carbocation is more stable than the secondary carbocation, which is more stable than the primary carbocation. And what's the idea behind it? The idea is the positive inductive effect, the alkyl positive inductive effect, right? Inductive effect. An alkyl positive inductive effect का क्या मतलब है? That the alkyl groups, they are electron donating. They tend to push electrons towards the positive charge, stabilizing it, spreading the charge out, and therefore the tertiary carbocation becomes more stable because it has more alkyl groups to it. So greater positive inductive effect. Right? Great. Now, which mixture would produce the most stable carbocation intermediate? Obviously, the one that has a tertiary carbocation, or in if all the options, the one that has tertiary would be the greatest. If not, then the secondary would have been the most stable. And then, if not, बल्कि होगा तो होगा, primary तो most stable होता नहीं है. खैर, let's talk about it. So, effectively, you just need to make these compounds, right? So, ethene is tuck tuck. Now, ethene, look at ethene. Ethene has this carbon right here in ethene fella, and this carbon right here, it's only bonded to, if you look at the left carbon, it's only bonded to one alkyl group, and if you look at the right carbon, it's only bonded to one alkyl group. So this is a primary, this will give you a primary carbocation intermediate on both sides of the double bond, right? Then if you look at methyl propene, meth at the proper, and methyl propene means what? That you have methyl right here. And this is propene. Now, if Br2 were to react here again, if you look at this carbon, the one on the left hand side, it's only bonded to one alkyl group, which is this fella. So this will give you a primary carbocation intermediate. And if you look at this carbon right here, this middle carbon, it's bonded to an alkyl group on the top, it's bonded to this alkyl group, it's bonded to this alkyl group. So when this double bond breaks and the positive charges were to form, this positive right here, this is the most stable carbocation intermediate, because this is what? This is a tertiary carbocation. So effectively, what should be your answer? It should be what? It should be C, by the way. But let's all check out all the other options. Propene plus bromine. Tuck, tuck. This is propene plus bromine. This fella, the left carbon, is bonded to only one alkyl right here. So this will give you a primary carbocation intermediate. And this fella, this carbon, is bonded to one alkyl here and one alkyl here. This will give you a secondary carbocation intermediate. So D is also wrong. Because see, we also have a tertiary fella. And then if you look at A, why is A wrong? Because pent 1-ene. 2, 3, 4, 5, that's pent. 1-ene means you have a double bond between the first and the second carbon, and 3 dimethyl. So on the third carbon, you have tuck methyl here, right? Now when the double bond breaks, look at this carbon right here. This carbon is bonded to an alkyl group here and an alkyl group here. So this carbon will give you a secondary carbocation intermediate when the double bond breaks, and this carbon right here will give you a primary carbocation intermediate when the double bond breaks, because it's only bonded to one alkyl group, which is all of this big chunk, right? So effectively C wins, because that is the tertiary carbocation intermediate, which is more stable because the alkyl groups are electron pushing, electron donating. You shouldn't use the word electron donating. They are, you can use it, but you could say they have a tendency to push the electrons towards the positive charge, stabilizing the charge, and therefore the charge spreads out, and this effect is effectively called the positive inductive effect of the alkyl groups. Since it's more alkyl groups, the greater the positive inductive effect, and therefore the more stable the carbocation intermediate is. Next, lactic acid is an intermediate in the manufacture of synthetic fiber. See, these MCQs actually also develop a lot of Cambridge is worldwide known for these things. Cambridge, when it tests these MCQs, it actually gives you real life examples. Agar aap Cambridge, if you start reading the theory paper and the MCQ papers for Cambridge, even if you are prepping for an interview or if you want to pursue a career in chemistry, even reading these past papers will help you a lot, because see, it gives you so much. They don't lie in their questions. So if he's saying that lactic acid, lactide is an intermediate in the manufacture of synthetic carbon, it actually is. This is an information for you. You can do further research on it, and that's what Cambridge is most known for when it comes to its testing. It tests very beautiful concept, gives you real life, practical, hands-on ideas. That's the beauty. That's what PSN and Excel fails to do. PSN and Excel ये नहीं करता. आप चेक कर सकते हैं बेशक. कोई बोर्ड इतने लेवल में डिटेल में, क्योंकि कैम्ब्रिज are effectively the Cambridge board में the people who design your papers are effectively researchers. So सारे researchers होते हैं. खैर, which compound on heating with an acid catalyst can produce lactide? Okay, lactide बनेगा. Now, which fella can produce lactide? If you look at all of these, hydroxyethanoic acid and 2-hydroxybutanoic acid, 2-hydroxypropanoic acid, 3-hydroxypropanoic acid. If you look at all of these, you also realize that if you look at lactide as well, look at even lactide. ये lactide और कह रहा है कि which compound on heating with a catalyst can produce lactide. If you look at this fella, it seems like symmetrical to some extent. मुझे तो ये symmetrical लग रहा है. And if you look at this, there is ester linkage here. See, the carbon double bonded to carbon is bonded to an oxygen here. Right here, this is an ester linkage. So if you heat, if I do reverse working, I want to do reverse working first, right? So if I were to hydrolyze the ester linkage, he's given me lactide structure. If I were to hydrolyze this bond would break right here. And if you check this out, see, this bond would break, C double bonded to OO, this bond would break. And the carboxylic acid would get back the OH, carboxylic acid gets the OH, and the alcohol would get the H. So I can effectively, if I were to draw the structure of this fella after hydrolyzing it, what do I get? And then I'll do the proper working with you guys, right? But I want to first do reverse working. I just want to hydrolyze it, just because my brain is telling me to do so. Achha, so what do I get? I get carbon. See, this is one node. This is the other node. That's the other node. So 3 carbons. Tuck, tuck, 3 carbons. And here you have C double bonded to O, OH. I hydrolyzed this. And this is 1 carbon right here. And it's bonded to the OH. And then you have this top right here, right? So this carbon is bonded to the OH right here. Now, if you look at this, और थोड़ा सा मैं इसकी तरह ही बना देता हूँ ताकि it's easier for you guys to visualize and make it like he has made it. Although it's the same thing, but and make it like he has made it, right? If you look at this fella, on both hand sides, you have the same idea. Even if you take this idea, this guy, and you want to make this back, this I've hydrolyzed it. So if you want to make the left hand side of it and the right hand side of it, it's literally symmetrical. You can even make this side of it, it'll be exactly the same fella. So what you realize is, hey, lactide is basically made from one fella, and it's basically esterification which is taking place. You take this fella and you heat it with an acid catalyst and you end up with this type of structure. And that's why in the options he's not giving you 2 things, he's just giving you 1 thing. Why? Because understand that normally when we talk about esters, we say that esters are made when an alcohol reacts with an acid, a carboxylic acid, right? But even in the options, he's not giving you alcohol and acid separately. So you realize that there must be this one molecule which has the acid bit and which also has the alcohol bit, and you're using the same molecule and heating it with a conc acid, and that ends up giving you guys the ester, right? So I just hydrolyzed this fella to figure out which molecule do I have to basically heat it with an acid catalyst for them to join together and give you guys a beautiful ester, which is lactide, right? So this is the fella. Now if I were to now name it, this is 1 carbon, 2 carbon, 3 carbons, right? And if you 3 carbons, you have a carboxylic acid and an alcohol. The alcohol becomes the substituent, it becomes hydroxy, right? Carboxylic acid has higher priority. So this is 1, 2, 3. You have 3 carbons right here. What is this? Propanoic acid. 3 carbons is propanoic acid. So it's propanoic acid. And on the second carbon, you have OH. So it's 2-hydroxy propanoic acid. And see, this is how I did it. Literally, I did not check out every single option. Some teachers, they would tell you to check out every single option, but sometimes you also have to use your brain. When I looked at this molecule, my brain was telling me, yeah, this looks like something very symmetrical. Why not just break the ester linkage and try to see whether it's symmetrical? And it was symmetrical. So I realized that there's this one molecule and its name is 2-hydroxypropanoic acid, which when you take it and react it with, heat it with an acid catalyst, which is normally conc sulfuric acid or conc phosphoric acid, you end up with an ester. So I realized that it must be 2-hydroxypropanoic acid, and that is C. Or you could also have, what you could have done is, if you wanted to waste your time, you could have selected this option, this option, this option, and tried to perform esterification and come up with a structure like this. And that would have taken a hell lot of time for you all. Yeah. Any question? Done. Next, guys. Compound Q can be hydrolyzed by HCl two products of this hydrolysis have the same empirical formula, which is the simplest whole number ratio of all the atoms or ions in a compound. Now, since we are talking about a molecule, so it's the simplest whole number ratio of all the atoms in a molecule for this case scenario. Now, it's saying hydrolysis ho raha hai. And obviously, if you look at all these structures, this is a carboxylic acid. CO2 means what? Carbon double bonded to oxygen, singly bonded to this oxygen, and then it is CH2, CH2, and this is OH right here, and this is CH3. Now, when you perform hydrolysis, what happens? The ester linkage breaks. You end up with meth, you end up with ethanoic acid, CH3COOH. This is what you end up with here, and this was meth, this was ethanol, which is the entire name of this fella is ethyl ethanoate. But this will go back into ethanoic acid, this will go back into alcohol, right? But remember, not just any alcohol, this already has the OH. So it's gonna, the alcohol, the O which formed the ester will gain back the H, right? So effectively you have OH, then it's CH2, CH2, and it also had another OH. It's effectively a diol, ethane 1,2-diol. Now, if you guys can check this out, do these two have the same empirical formula? Check this out. First, write the molecular formula. This is C2H4O2, and this fella is C2H246, H6O2. Can you simplify this? It gives you CH2O. When you simplify this, divide all of them by 2. And if you simplify this fella, but by dividing 2, 6, and 2 with 2, 2 ratio 6 ratio 2, it gives you what? Divided by 2, what does it give you? 1 ratio 3 ratio 1. So it's 3, so CH3O, and this is not equal to this. They must have the same empirical formula. So A is wrong. Then let's check out B. Let's check out B. Acha, before I check out B, I can eliminate D. Why can I eliminate D? Because see, eliminating D is very, it's very logical because it's not an ester. Alcohol ka KD hydrolysis hota hai. Have you studied anything that in organic chemistry up until now where I've said that alcohol is hydrolyzed? You haven't studied anything of such sort, have you? So you can eliminate D out. This is just one fella. Now between B and C I have to select, so I'm just going to go with what the examiner has done, right? So you have CH3, CO2, CH3, and it's CO2 which is carbon double bonded to oxygen, singly bonded to O. Then it's CH2, 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 CH2. Then you have C double bonded to O, OH, right? So C double bonded to O, OH. This is what you guys have. Now, when you hydrolyze it, the alcohol has no effect on hydrolysis. It's basically the ester linkage which breaks when you hydrolyze it, right? So I'm going to hydrolyze it. The COO ester linkage would break. This fella, the C double bonded to O, and this CH3, this came from the acid. So we're going to get back the acid, CH3, C double bonded to O, OH. This is what I'm going to get. And this fella came from the alcohol. So this is going to get back the H, right? So you're going to have OH, CH2, CH2, and CO2H. Done. Now I'm gonna write the molecular formula for both, and then I will see whether they can have the same empirical formula. So it's 2 carbons. How many hydrogens? 3 plus 1, 4 hydrogens, and 2 O's. This gives me CH2O as the empirical formula by dividing 2, 4, and 2 with 2. Simplifying 2, 4, and 2. I hope you guys can do this. I'm doing this directly, but I hope you know what I'm doing here, right? 1 ratio 2 ratio 1. And CH2, CH2, CO2H, what is the molecular formula? 1, 2, 3. You have 3 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6. 6 hydrogens. How many O's? 2 and 3. 3 O's. Right, so can I simplify this? It's 3 ratio 6 ratio 3 divided by 3. It can be further simplified by dividing it by 3. What do you get? You get 1 ratio 2 ratio 1, and that is CH2O. And are these two equal to each other? Yes, CH2O is equal to CH2O. And that is why B is the correct option. I'm not even going to look at CR because it's going to just take time. You can check C out and do the same process here, and you're going to realize that C would not be the option. Just give me a moment, guys. ما podíamos conocer que srem igi ala sta rosto wala dol dak te pake de ya sahalo ka kana ya sabah se chalo ka din khane spinal wal best pre karbo mane se chalo ka sabah jo office tala tam se chalo ka jida se pa youtube bane ugora chi singa hal da dera uka ge se chalo wala rauka ka se tam khande wala ka ko chal mo ha da khan chal da wala chal ka يا تشاني كخوفي على كيخا كي ديش بي ماجي ماجي خرما يسرى بيا رود خدا أسود ماجي خطر أنا كوني أتني أتني تبقى ظهر مهاري بروتي. Continuing, Egg is saying, will this be uploaded on? Guys, are you guys जिंदा हो सारे? जिंदा हो? Give me a moment, हाँ? जिंदा हो सारे? जिंदा नहीं, जिंदा नहीं. थोड़ा सा ब्रेक ले लेते. 5-10 मिनट की ब्रेक ले लें. 10 मिनट की ब्रेक. Let's take 5 minutes break, huh? Then we'll continue. मजा आ रहा है? Enjoying everybody. नहीं नहीं, D would not produce anything यार. Hydrolysis of acids किधर पढ़ा हुआ है आपने? Hydrolysis, sorry, hydrolysis of alcohols. केडी पढ़ा हुआ है हाइड्रोलिसिस ऑफ अल्कोहल? अल्कोहल की हाइड्रोलिसिस आपने किधर पढ़ी हुई है? पंजाबी मैं नहीं बोल रहा था, मैं पश्तो बोल रहा था. आनिया सिंह, आई डोंट एंजॉय केम. आनिया, रिलैक्स. So can we do a case on Cambridge for giving us so much stress? No, because you're voluntary giving the exams. Oh. Hi guys, what's up? I am back. Did you guys see my football? As देखें, there are a couple of ways when you study or when you work. Hey, these sessions will also help you get the brain. Yeah, when you work, you can never work efficiently for more than 45 minutes to 1 hour. More than 45 minutes to 1 hour, you'll burn out if you study at a stretch 2 hours, 3 hours. So always, even when I'm taking my marathon, I give you guys break. I talk try to do an exercise, like try to do a push-up or so. Do a push-up, do like 10 jumping jacks like this. Do this, hold your head, do something that would increase or make your adrenaline go faster. Because what that does is, it's scientifically proven, when you work out, or like take 5-10 minutes to walk or just refresh your brain, what I tend to do is I start kicking my football, or I start writing on the board which is in my room. I just write, scribble, 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 scribble. What that is that resets your efficiency. You go back to 100% efficiency. Because there was this research carried out, that one mice on mice it was carried out. I don't remember the exact research, you can search it up, but one used to first work out, or it was carried out on humans, that the humans who used to work out first and then do a task, and the ones who used to just sleep or eat and then do some, there was a hell of a difference between the results. So always try to do 5-10 minute get up. मर मुर नहीं जाओगे. You don't have to study at a stretch. Always take a 5 minute, 6 minute, 10 minute break. You only need 5 minutes of break. Just do like 2-3 push-ups. Do this. Shoo shoo shisha shoo sha shi sha sha, and you'll be good to go. Just like I did. Sir, you're so cool. I wish I had studied from you before RT. बस यही होता है. Our teachers are this, our teachers are this. मेरी तारीफ के साथ ना बाकी आर्ट टीचर्स की भी आप लोग कपड़े उतार रहे हो, तो वैसे ना किया करो यार. मैं कर सकता हूँ, कि मेरे तो इफेक्टिवली कुलीग्स बनते हैं, चाहे जितने बाबे हों मेरे कुलीग्स बनते हैं. मैं कह सकता हूँ आप लोग मतलब, और मेरी तारीफ करनी कर लिया करें, और टीचर्स को बस छोड़ दे, रहने दे. सीख जाएंगे इंशाल्लाह. ठीक है ना, सीख जाएंगे, कभी ना कभी तो सीख जाएंगे. We continue. Which two-step process converts cyclohexanol into cyclohexane 1,2-diol? Okay, and he's even giving you the structure. So kind of him. Sir, आप बहुत क्यूअल हैं, वाह. What's क्यूअल? So he's so kind enough to give you even the structures. And if you check this out, the beauty here is that even if the options weren't given to me, cyclohexanol is an alcohol and there must be two steps involved. He's saying two steps are involved. And if you check this out, there's a diol here. What that clicks in my brain is, see, I'm not going to even look at the options. What should come in your brain? If you've taken those marathons, what should come in your brain? Okay, diol, how do diols form? Alkene se bante hain. Alkene se kaise bante hain? Cold dilute acidified aqueous potassium manganate. Okay, so alkene. So I need alkene. I first need to go from cyclohexanol into an alkene. This is literally how I think. I go into an alkene and then from alkene into the diol, right? Now, how do you go from alcohol into alkene? Okay, how? Dehydration or elimination is the same idea, right? You either call it dehydration or elimination. And what do you use? You either use Al2O3 and heat strongly, or what you do is you use conc acid and heat. Yeah, conc acid and heat. So conc acid and heat, and which acid normally? Sulfuric acid. Conc sulfuric acid and heat, because sulfuric acid is a good, concentrated sulfuric acid is a good dehydrating agent, not dilute. Dilute sulfuric acid is not a dehydrating agent, please. So you're going to end up with an alkene, and probably, the structure of that would be something like this. And then I would do what? I would add cold dilute acidified aqueous potassium manganate to it, but cold dilute, and the double bond would break. You're going to get an OH here, or you're going to get this directly. I don't even have to make, but this should be cold dilute. This is how your brain should work. And now let's also look at the options. So first step is to go into the alkene, which is either you heat it strong or conc acid. You're not given the option of conc acid, so A and B should be the options. Ethanol. Now see, he's saying heat under reflux with sodium hydroxide ethanolic. This was the idea of converting NaOH. Ethanolic is what? It is when you take haloalkanes and you want to convert them into alkenes. This is what you use. You use NaOH ethanolic, right? Elimination reaction takes place. So A, C, and D are wrong. Then A and B में step 2, it says add steam with H2SO4. What the hell? If you add steam with H2SO4, listen to this very carefully. If you add steam with H2SO4 and also provide the temperature of 300 degrees Celsius, 60 atmospheres, and the H2SO4 is dilute, or you use dilute phosphoric acid, you're going to end up with electrophilic addition reaction, and you're going to end up with the alcohol. Absolutely, the alkene will convert into alcohol, but remember, it will convert into the same thing. You're going to get the alcohol, but it's going to give you one OH and one H being bonded, because effectively you're adding steam, you're adding a hydrogen and an OH. So we're going to end up with the cyclohexanol once once again, you need a diol. For diol, you need cold dilute acidified aqueous potassium magnate. Why does it say H2SO4 here? Because he's just elaborated on the acidified bit. Normally what we do is we say it's acidified aqueous potassium magnate. Acidified literally means you have a lot of H plus ions. Where would these H plus ions come from? They come from sulfuric acid. So he's just elaborated on it. That's why is the correct option. Next, compound X C7H13Br reacts with hot alcoholic NaOH. See, he's gonna try to play these mind games with you, but alcoholic NaOH, मतलब alcoholic का मतलब है ethanolic. Not the henny man. What the henny? What the henny? He basically means ethanolic. Now, if it's ethanolic, we know that if you have a haloalkane, always think broadly first. If you have a haloalkane and you have sodium hydroxide ethanolic, what would happen? Where would this fella go? Shabash, elimination reaction would take place. You're going to end up with an alkene. Broadly, just always broadly think about things, right? And obviously, this is heat under reflux if I were to write the conditions as well. It says it produces two compounds, Y and Z. Okay. Now, why would two compounds be formed? Because see, effectively, when you perform the elimination reaction, you say that HBr is eliminated. Although you know that H2O forms and NABr forms. If you watched my organic chemistry marathons, I've debunked the myth that HBr does not form. NABr would form or KBr would form and water would form. HBr wouldn't form, but it's a good way to think about things. HBr would be eliminated, right? So we know that the carbon which has the Br, how does elimination reaction take place? The carbon which has the bromine atom bonded to it can have an adjacent carbon with the hydrogen, and that HBr would be eliminated. What that means is this carbon, where is it adjacent? The carbon with the Br, where is it adjacent carbon? Its adjacent carbon is either here or here. Now the left hand side and the right hand side are both the same. I can either eliminate this hydrogen and this Br, the double bond would come here. I can either eliminate this hydrogen and this Br, the double bond would come here, but there's no difference between left and right. So I'll just stick with the right bit. Left or right, no difference. So the first product that could form here is when the Br, the carbon with the Br and this carbon with the hydrogen, these two H and this HBr goes, and you end up with one product that looks something like this. The other possibility is the other adjacent carbon. Where is the other adjacent carbon? This carbon with the Br. This carbon with the Br also has a carbon with the hydrogen. So it can also be this H and this Br being removed. This H and this Br. Obviously, later on it forms NABr and H2O. That's the other idea. But this HBr can also be removed, and you're going to have a carbon-carbon double bond right here. So effectively, this can also be the possibility, right? So it's either this or this. These two possibilities can happen. Yes, the possibility, and obviously this methyl is as is. Sorry, I forgot to add this. This CH3 is as is right here when the double bond form here. So either this possibility or this possibility can happen. That's why he said two products can form. Now let's look at the other possibility. Before I discuss any option, my job here is to help you guys think. Before I discuss any option, I have to discuss two possibilities, right? Now look at this carbon right here. If you look at B में क्या है? B में क्या है? You can end up with what? You can end up with, this is a carbon which has the Br right here, the carbon which has the hydrogen and the Br. Now when you want to eliminate something, you can't have, this is very crucial to understand. It's not possible. And why is it not possible? Watch my organic chemistry videos in which I've taught you guys mechanisms. It's not possible to, when in elimination reaction, it is not possible that the hydrogen and the Br on the same carbon are eliminated. No. You must have a hydrogen on the adjacent carbon which would be eliminated with the Br. It can never be the hydrogen on the same carbon, which can be, this can never happen. Remember this can never happen. Why? I've shown you the mechanism of elimination reaction in my organic chemistry marathons, which you don't need to know. But it's because of that mechanism due to which you realize that the carbon which has the Br must have an adjacent carbon with the hydrogen, and that H and Br can be eliminated. Not the carbon with the hydrogen and Br. The carbon which has the hydrogen, the same carbon also has Br. This HBr will not be eliminated. No. It must be the adjacent carbons hydrogen and the Br involved. Remember this. So realize that if you have a CH2Br, this HBr can never be eliminated. You can remove the hydrogen from this fella and the Br from this fella, or the hydrogen from this fella and the Br from this fella. So two possibilities can happen, the left and the right. But since the left and the right are both the same possibilities, it's a symmetrical fella from anti-clockwise and clockwise, you realize that it only gives you one product, which is what? Which looks like this. It only gives you one product that looks like this, guys. Done. This is what it gives you, because if you put the double bond here or here, it's the same idea. So it gives me one product, not two products. That's why I can eliminate B off first of all. Then if you look at C, C can give you two options. What? The carbon which has the Br, it can take the hydrogen from the adjacent carbon on the left, or it can take the hydrogen from the adjacent carbon on the right. So effectively, you can have two fellas. You can have a double bond forming here, or you could have a double bond forming here, right? And this is effectively, I can even write CH3 here if you want. Normally you shouldn't. You can even write CH3 right here. This will become CH2. In this case, this is CH3 if you want to write it for the sake of writing, right? Normally we don't write it, do we? Next, so here C can potentially be my option, even A on C and O C, even an A. And if you look at D, maybe you can have two possibilities. This carbon can have this hydrogen eliminated with itself, this hydrogen, so a double bond would form here. This carbon can have this hydrogen eliminated with itself, and a double bond can form here. So effectively, you can have this, and you can also have this, right? So you can have these two possibilities taking place here. So I can eliminate what I can eliminate, but I can eliminate only B out when I CKHR two products are going to be formed. Now he's saying which are Y and Z. Now he's saying on the reaction with Br2, Y gives this fella C7H12Br2. Obviously, because addition reaction takes place, the double bond breaks and Br atoms are added on both sides. Now he's saying which exists as a mixture of four optical isomers, and if you react Br2 with Z, it gives you a carbon which is non-chiral. मजे का सवाल है, मजे का सवाल है. So he's saying that in all these options, instead of this, because this only gave you one product, in A, C, and D, now you have to look at them, because you've said, okay, two possibilities are here, two possibilities are here, and two possibilities are available in D. Now when I react Br2, one guy will give me four optical isomers. Effectively, you are going to have two chiral centers. And one guy, when I react it with Br2, it is not going to give me what? It is not going to give me any optical isomer. That's what he's saying. So let's try to figure it out. Now, when you react this fella with Br2, the double bond will break. One Br will come here and the other Br will come here. I can even show it to you. CH3, one Br will come here and the other Br will come here. And this is CH3, by the way. Now check this out. The carbon, this carbon, is it a chiral carbon? Absolutely. Why? Because it's bonded to four different groups. Why? This carbon is bonded to CH3, it's bonded to Br, it's bonded to all of this side, and it's also bonded to this side. And since it's asymmetrical, see, the anti-clockwise is not the same as clockwise, or clockwise is not the same as anti-clockwise, because here the Br comes first, here the Br comes on this part. So it is a chiral carbon. So yes, this carbon is chiral. This gives you two optical isomers. And if you look at this carbon right here, this carbon is bonded to Br, it's bonded to this fella, it's bonded to this fella, and the clockwise and anti-clockwise aren't same. So these are two different stuff. And the third bond is with hydrogen. So even this guy is bonded to four different atoms or four different groups. That's why you have two chiral centers and 2 to the power of 2. That gives you four optical isomers, don't they? Right? So it will give you four optical. So isn't the product you drawed for option B wrong? The double bond, shouldn't it be between the alkyl and the CH? Alkyl and the CH for B? What do you mean alkyl and the CH? You can unmute yourself, Huma. Unmute कर ले, देख लेते हैं. See, this is CH2Br. This Br can be eliminated with this hydrogen. So a double bond would form here. Or it can be eliminated. अच्छा हाँ, ये कहना चाह रहे हैं. अच्छा ये कहना चाह रहे हैं. Wait, are you saying this? ये तो फिर CH3 हो जाएगा ना, कि इधर से Br उठेगा, इससे निकल, इसके साथ रिएक्ट कर जाएगा, इससे Br उठेगा, इससे रिएक्ट कर जाएगा. So you're only gonna have what? You're only, oh sorry, my bad. You're right. My bad. You're absolutely right. It should be like this. Huma, you're right. Thank you for correcting me, Huma. It should be like this. Why should it be like this? I'll tell you. Huma is right. Huma thinks that you said that it must be with the adjacent carbon. This is not the adjacent carbon. Huma, thank you so much. This is not the adjacent carbon. The adjacent carbon for CH2Br is this carbon. And this carbon has one hydrogen only, this hydrogen. So it would be this H and this Br, which would be eliminated, and you're going to have a double bond with CH2. Thank you, Huma. Thank you. देखिए मैं भी इंसान, गलती हो जाती बिल्कुल, but still it's only a single product. Thank you, Huma. Means a lot, kiddo. डन, बस अब आहिस्ता आहिस्ता दिमाग फ्राई होने लग गए। लकीर के फकीर है ना बाकी सारे। अच्छा, so again, even then it's just a single product. Done. So this gives you two optical isomers. And if you look at this fella right here, this fella, when I react Br2 with this guy, you're gonna get what? You're gonna get tuck, 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 tuck. The double bond breaks. You get one Br bonded to this fella and one Br bonded to this carbon right here, right? So I'm gonna call it CH2Br right here, and one Br would bond to this carbon right here, Br. Now the question is this carbon chiral? Is this carbon chiral? बताएं जी, किसी को पता है कि ये कार्बन कार्बन है कि नहीं है? सर आपने हाइप कर दिया, थैंक यू। नहीं नहीं होमा, तो आप अटेंटिव है ना, यू आर अटेंटिव हियर। इज दिस कायरल कार्ब? Remember, this carbon is not chiral. Is this chiral carbon? This carbon is not chiral. Why? Because even though you might think it's chiral and it's going to give you an optical isomer, or though optical isomers again, no. Why? Because this carbon is bonded to this alkyl, this bit right here, CH2Br. This is a different group. That's a different group of atoms. But if you check this part out, the anti-clockwise and the clockwise cycles, they are both the same, which means this is a symmetrical fella. And we've studied that whenever you have a symmetrical cycloalkene or symmetrical cyclo compounds, they are never going to show chirality. Symmetrical. So non-superimposable images of each other will never exist. I've proven it in my live classes even. So it's symmetrical, right? So this in fact is not chiral at all. No chiral centers. No chiral centers. And should I have to check all the other options out? I shouldn't, should I? Because it says this is effectively now Z and this is Y. So in the first option, I figured out that one is Z and one is Y, and this is, one is giving me 4 optical isomers, one is giving me non-chiral. It must be A. Right? And if you check C and D out, you can check C and D out. आप इधर BR लगा दे जाएं. See, if this double bond, now I'm just going to erase the double bond. So if I erase this double bond, I'm not going to make it. If I erase this double bond and I add a BR here, right, if I add a Br here and a Br here, this is also chiral carbon, this is also a chiral carbon. So you have 4 optical isomers here. But when I remove this double bond from here, when I remove this double bond from this side, I'm going to get a Br atom bonded. I'm going to get a Br atom bonded here, and I'm going to get a Br atom bonded here. Right? Now this fella is chiral, and it says that it must have no chiral carbon. This fella is also chiral, and this fella is also chiral. You can see this carbon is bonded to this entire fella. It's bonded to this entire file, is bonded to a Br and a hydrogen. This carbon is bonded to a Br, this side and that side, and a hydrogen. So they're all different. So in both cases, in these both cases, you're going to get 4 optical isomers in C. And if you look at D, the same idea. You remove this double bond, erase the double bond here, erase the double bond here. You're going to get what? You're going to get Br bonded here, Br bonded here, 4 optical isomers. This is also chiral, that's also chiral. And then you have Br bonded here, Br bonded here. This is also chiral, that's also chiral, because now it's asymmetrical, right? So in both cases, you get 4 optical isomers. Therefore, C is wrong, D is wrong, and A was the correct option. यार ये क्या है? 2023 लिखना है यार, इसके साथ क्या कर रहे हो? How many MCQs are left for 2023? Yaar, I'm tired. 21. Can you do some for? Oh, we are just left with 22 MCQ, 21 MCQ, 20th MCQ, and 19th MCQ. Do you want me to finish the 2023 set? We can finish it. Absolutely. Can we not? करें खत्म इसको. 21. Can you do some for me? Can you for me? I hate these questions. Question 19, I despise these questions because Cambridge shouldn't be asking such questions. Sir, I never get in cyclic which will be symmetrical, like when they are similar. No, Homer. It's very easy. In cyclic compounds, if you want to see whether there's a chiral carbon, firstly you have to check out is the carbon bonded to 4 different groups. And if it's bonded to 4 different groups, then you have to check out the cycles, because 2 of the bonds would be with the cycle, right? 2 of the bonds, see, if I show it to you, Homa, right here, you'll see, okay, this carbon right here, the carbon that I'm highlighting, this carbon is bonded to CH3, it's bonded to hydrogen, and it's bonded to this side and that side. But the problem is, that if I start cycling here, if I start cycling the left hand from the left hand side all the way up and from the right hand side all the way up, it's the same. So when you see the mirror image, they will effectively be superimposable on each other. They are not non-superimposable mirror images for each other because it's a symmetrical fella. But now if what I do is I put a CH3 here and I also put, like, let's suppose a Br here. Now this carbon will now be chiral and even this carbon will now be chiral. Why? Because if you look at this carbon, it's bonded to CH3, it's bonded to a hydrogen, and it's bonded to this side and this side. And if you check out the left hand side, it first starts with the Br right here. It first covers the Br and then goes all the way here. So the cycle which goes from left to right, which is anti-clockwise or clockwise, is not the same for the cycle which goes from right to left, because here the Br comes first and here the Br does not come first. So effectively these will be considered different from each other and they will be non-superimposable mirror images of each other. So effectively this is chiral. And similarly here, this is Br hydrogen, and when you start the cycle from, if you go like this in the cycle, the CH3 comes forward. If you go like this in the cycle, the CH3 comes there. So you realize, okay, the cycles are different, the sequence of the cycle is different. This is just a shortcut that I taught you right now. But I hate these type of questions, the Illudin S, and this he's just saying what is the molecular formula of compound M. So what he's saying is where Illudin S is heated under reflux with excess acidified potassium dichromate, compound M is formed. Now acidified aqueous dichromate के साथ हम reaction करें, acidified aqueous dichromate के साथ. What does acidified aqueous dichromate do? And we are heating under reflux. What that means is it's not going to give me aldehyde. If you have a primary alcohol, it's not going to give you an aldehyde, it's going to give you a carboxylic acid. Firstly, to yeah, in primary alcohol, it's directly going to give you carboxylic acid because the only way an aldehyde would form is if you heat and distill the aldehyde. Number one. Number two, if you have a secondary alcohol, it's going to go into a ketone. That's the idea behind this, right? So, and would it break the carbon-carbon double bond? No. Acidified aqueous potassium dichromate does not break the carbon-carbon double bond. What breaks the carbon-carbon double bond is potassium manganate, right? So everything else is the same. Wherever you see OHs, they will either go into carboxylic acid or into ketone. Now, if I start off with this OH right here, the OH which is bonded to this carbon, can you tell me what will happen to this OH? Now, this OH, first check it out. Which OH is it? Is it primary, secondary, or something else? This OH is bonded to one alkyl group. The carbon which has the OH is bonded to one alkyl group, the other alkyl group, the other alkyl group, and this is effectively tertiary alcohol. And tertiary alcohols are not oxidized, are they? So nothing's going to happen here. Tertiary alcohols aren't oxidized at all. If you look at this OH right here, this OH is bonded to alkyl group on the left, alkyl group on the right, and if it's bonded to two alkyl groups, that's a secondary alcohol and it must go into a ketone. So I'm going to put a double bond and I'm going to erase this hydrogen. Can I erase it with the help of can I erase it like so? No, I can't. I thought we could erase it like so. I think the app has finished this type of option. This is what's going to happen. I'm going to erase the H like so. Then you have, where else do you have alcohol? Right here. See this alcohol now, the carbon which has the OH, this carbon is only bonded to one alkyl group. What that means is the alcohol is going to be converted into carboxylic acid because it's a primary alcohol. So you're just going to add double bonded to O here. Primary alcohol goes into carboxylic acid. Now let's count the carbons, hydrogens, and oxygen. Now some silly students, what they're going to do is they're going to start to count the number of carbons first. Oh khudara wasta, don't count the number of carbons. Why are you counting the number of carbons? Because in all options you have 15, 15, 15, 15. So Cambridge also tests your ability to look at the options as well. Please aankhein khol ke, why would you waste your time for counting the number of carbons? You wouldn't waste your time to count the number of carbons, would you? Because they're all 15. It wouldn't matter if you count them or if you don't count them, you know. So they're all 15. I'm not going to count any carbons at all. That firstly. Secondly, he's saying about the oxygen. Now in one option it is 4, 5, 4, 5. So it can help me eliminate two options, right? Here I have 1 O here, 2 O here, 3 O here, 4 O here, 5 O here. So the one which is 4 O's, which is C and A, I can easily eliminate these two. Now I just need to count hydrogen. In one case it's 16. Sorry, in one case it is 16 in B and in D it is 18. So whether it's 16 or 18, let's count it out. Let's start. So this is 1, 2, 3 hydrogens here because carbon is bond shown, right? So it's bonded to 3 hydrogens. This carbon is made 2 bonds, 4, 5, 6, 7, 6, 7. This carbon, no hydrogen. This carbon, no hydrogen. This carbon, 3 hydrogen, right? So 7, 8, 9, 10. Then 11, right here I counted this. Then this carbon, no hydrogen bonded. This carbon, one hydrogen, no hydrogen bonded because it's double bond, one bond, one bond. So 11, abhi tak 11 mein. This carbon, one hydrogen bonded, 12. Then this carbon, no hydrogen bonded. This carbon already made 4 bonds, no hydrogen bonded. This carbon already made 4 bonds, no hydrogen bonded. This carbon already made 4 bonds, no hydrogen bonded, right? So 12 tak pahunch gaye. Then this 13, 14, 15, and then this one is the last 16. So 16, I think it was just basic counting, therefore B should be the correct option, not D. It's a good question, Danny. Danny said, till which point will we go when you talk about the cycles? When it's a huge structure, Danny, then you just start to see thoda jai, you're gonna see the difference between the two cycles. You will always see the difference if there is any difference. You'll always see it. So you just go like, oh, okay. Here the CH3 is coming here, but if I start the cycle from this side, this CH3, the same CH3 is gonna come like this. You're gonna see, acha, they're not the same cycles. Yeah. So you don't actually have to complete the entire cycle. Just see the difference between the left and the right cycle. Acha, the substituents that are attached to it. In the left case, the substituent comes on the second, and the same substituent, if I start from the anti-clockwise, is gonna come on like this. It's gonna come later on. So that's what you realize. Ki, acha, kya reality to hai. It's asymmetrical. Then tartaric acid. Oh my god, I'm so tired. My gala is now starting to hurt slowly. Tartaric acid is found in many plants. A sample of tartaric acid reacts with LiAlH4 to form organic product J. What happens when sodium hydroxide is added to separate samples of tartaric acid and organic products? Now I'm not going to even make organic products. You see, this is tartaric acid. It has the COOH fella and it has COOH fella. And you know that LiAlH4, it basically reduces the carboxylic acid into primary alcohol, reduces the carboxylic acid into primary alcohols, right? That's what's going to happen. Instead of COOH, you're going to get the OH only, right? Now that's the idea. And this is what product J is going to have. I'm not going to make it because it's irrelevant. Now he's saying what will happen when NaOH is added to separate sample of tartaric acid NJ. Now when you add it to tartaric acid, NaOH is a base or an alkali, right? Alkalis are soluble bases, and alkalis, they react with the acid part. So they're going to react with tartaric acid, wouldn't it? Alkalis would react with tartaric acid. It would. So I'm going to tick this. NaOH would react. But when J forms, J is what? J is going to be, this will become primary alcohol. This will become primary alcohol. And this is alcohol. And alcohols, they don't react with sodium hydroxide. They react with sodium metal, not sodium hydroxide, with sodium metal. They're not acid. They're slightly acidic for sodium to react. Right, so you understand that J will not react with sodium hydroxide because there's no acid present. So it's only tartaric acid which would react. See, that's why I did not make product J, because when I looked at it, I was like, अच्छा, product J बनाने की जरूरत नहीं है. आप बना लें यार, मैं अब थक गया हूँ आहिस्ता आहिस्ता. So I am tired now. Done, guys. Dun. See, now he's saying citric acid can be converted into tricarboxylic acid, right? In 2 stages. An intermediate Q is formed. What is intermediate stage? Now, see, he's given you LiLH4. Now I'm just going to look at the options because I just can't be bothered to think that much. But acha, chalo, look at stage 1 and then stage. Look at the difference between them. Here you had CH2, COH, CH. In all cases, on right hand side you have COH, COH. The only difference is that this OH is now not present in stage 2. Is it? No, it's not. So what would effectively have happened is, what I think is that this OH, I would have removed this OH. How do you remove the alcohol? You either remove the alcohol by going into haloalkanes, or you can go into alkenes, right? Or you can go into carboxylic acid. Now obviously you haven't gone into carboxylic acid because then this would also be COH. So you can either go into alkenes or haloalkanes. If I react it with something from the perspective of haloalkanes and put a Cl atom here or a Br atom here, and whatever this forms, the Cl atom or the Br atom cannot be replaced by a hydrogen in, I have not seen any reaction in organic chemistry. This is how you think, right? So Cl atom को अब हाइड्रोजन से कैसे रिप्लेस करेंगे? There's no idea. But yes, I know something. If I go into alkene, which is effectively if I use elimination reaction or dehydration reaction in which alcohols are converted into alkenes, what would happen is the OH and the adjacent carbons H, this part, the OH and the adjacent carbons H, it can be the top hydrogen or the bottom hydrogen, I couldn't care less, but these two fellas are going to go, dehydration is going to take place, H2O is going to be eliminated, and a double bond would form here, right? And then after a double bond forms here, what would happen? When a double bond forms here, this hydrogen left, this became CH now, and the OH left. So this is CH double bonded to C. And so an alkene formed. And then in stage 2, what are you doing? You're adding hydrogen to it effectively. This is what I think. You're adding hydrogen and nickel solid and heating. So what happens is the double bond breaks. This CH will get back the hydrogen, and this carbon will now get the hydrogen. So see, this became CH2 again, and this is hydrogen. This is what I thought. अब देखते हैं options क्या हैं. Concentrated sulfuric acid, yes, because you could use either Al2O3 and heat, or you could use conc sulfuric acid because it's a good dehydrating agent and heat. So yes, it's either A or B. It can be LiAlH4 because LiAlH4 is a reducing agent. It would have reduced all of these carboxylic acids into primary alcohols. Sodium hydroxide aqueous couldn't be used. Why? Because sodium hydroxide aqueous is basically what? It's used for haloalkanes and it's for nucleophilic substitution reaction. Either haloalkane किधर से आ गया. So D is wrong. And then stage 2 में you don't reduce this because if you used a reducing agent, all of this would have gone into primary alcohol, and that's not possible. That's not the idea here. So B is wrong. A is the correct option. C, hydrogen gas or nickel solid डाल दें. लगे हूँ यार. Literally, I think this is the last MCQ if I'm not wrong. Oh, finally. Two isomeric alcohols, W and X, have the molecular formula C4H9OH. Okay, C4H9OH. So it's basically four, it's like butanol, and maybe one is a secondary alcohol, and in one case you have the primary alcohol, right? So if one is primary, one is secondary. Good. Now it says W is oxidized. Let's call this W and let's call it X. So W is oxidized to give a carbonyl compound which gives a red precipitate with a Fehling solution. This cannot be W then. Sorry, this can't be W. The other fella is W. Why is the other fella W? Why is this fella W and why is this fella X? Because see, it's saying it is oxidized to carbonyl compound. Why? When you have a primary alcohol, it can be oxidized to a carbonyl compound which is aldehyde when you use K2Cr2O7 acidified aqueous potassium dichromate aqueous, and what do? You heat and distill. So what happens? You end up with an aldehyde, and then this aldehyde further gives you a test with a red precipitate. It gives you a red precipitate with Fehling solution, and that means, why does it? When I said it gives you a red precipitate with Fehling solution, that means that the carbonyl compound that you had was effectively an aldehyde, and aldehydes form from primary alcohols, not secondary alcohols. So that's the idea. W is effectively the primary alcohol. So this is what I figured out. It says X is oxidized to carbonyl compound Z and does not give precipitate. Yes, because X is a secondary alcohol, and secondary alcohols are oxidized to what? Ketones. And ketones do not give any test with Fehling solution or Tholen's reagent or whatever. So that's the idea. Now he's saying which of W and X gives a yellow precipitate with alkaline iodine aqueous. Remember, primary alcohols can only, this alkaline iodine and warming or heating, this only works for either if you have methyl ketones or if you have secondary alcohols, because secondary alcohols will convert themselves into methyl ketones, and then this methyl ketone is going to break apart, and I'll show it to you. And the only case it'll give you a primary alcohol ke saath test is if it is ethanol. If it's ethanol, and the only test it's going to give you with an aldehyde is if it is ethanol. These are the only four cases in which you're going to get tests out of I2 aqueous alkaline. The reason I've all taught it in the organic class and in the math on, because the alkaline iodine aqueous, even some people say that Hitler's mom died of this, or wife died of this. Mom, I think, his mother was, I think, poisoned with this scent. I think chloroform जो आपने सुना है ना, वो भी यही चीज है. So alkaline iodine aqueous, right? Now, why does it work for these four fellas? For primary alcohol, only these two, and for the other two, it can be methyl ketones or secondary alcohol, because this alkaline iodine will only give you a test if you have a CH3 directly bonded to carbonyl carbon. right? And see, a CH3 is directly bonded to carbonyl carbon, not in the case of any other aldehyde. It's only in the case of ethanol. If you check ethanol out, you have a CH3 bonded to a carbonyl carbon directly. After ethanol, there's no aldehyde which has a CH3 directly bonded to carbonyl carbon. No. And even in ethanol, why am I saying ethanol? Because see, ethanol, if you have ethanol, this will oxidize. Iodine is also oxidizing agent, right? This will oxidize into ethanol, and this ethanol will then give you a test right here. This fella will become the yellow precipitate, and this fella would go into the salt, which is CO minus Na, and then you could further acidify this fella and get carboxylic acid later on. So effectively, and this is yellow precipitate, this is how you end up with a yellow PPT. So effectively, if you want a test with alkaline, iodine, and aqueous and warming it, if I say it's a primary alcohol, it can only be ethanol. If I say it's an aldehyde, it can only be ethanol. No other aldehyde, no other primary alcohol are going to give you a test. But if I say it's a secondary alcohol, it can be methyl ketones. Which secondary alcohols? The one which will go into methyl ketones, right? Like for example, this secondary alcohol that I had, it will get oxidized first. You're going to get CH3C double bonded to O, and then this part would break, and you're going to end up with what? You're going to end up with CHI3, and which you call iodoform or triiodomethane, and you're going to end up with double bonded to O, tuck tuck, and this fella is become O my Na, and this will become this. So you're going to end up with a salt, and you're going to end up with this yellow precipitate here. That's why it's going to give you a test with secondary alcohols, which because they are going to go into ketones and methyl ketones. Methyl ketones just means that you have a CH3 directly bonded to C double bonded to O. Right? Although this is not the name for it, it's named something else, meth, eth, pro, but, it's called butanone, but methyl ketone इसको सिर्फ इसलिए कहते हैं कि it's carbonyl carbon with a CH3, right? So that's the idea. Now, out of all of this, I know that X is going to give me a test and W wouldn't. W would only give me a test if W were a primary alcohol, but a primary alcohol with two carbons, because it's only going to give you a test if it was ethanol. So out of all of this, insufficient data तो नहीं है भाई. W only, W नहीं ना, W नहीं देगा because it's an aldehyde, and the only aldehyde which gives you a test with this is ethanol. So W नहीं, X होगा, NTS. I'm tired. Any schwackens, guys? पूछिएगा जी, पूछिएगा जी, पूछिएगा. Did you guys enjoy it? Did you guys enjoy it? I hope you did. I can only hope you guys enjoyed the class. सर आपकी ईद शॉपिंग हो गई? Anya, I don't do my eat shopping. My mom just buys things. Yes, sir. When we'll do this again? Hopefully never. बस ना यार, थक गया हूँ, मेरी तो बस हो गई है. Michelle is saying me heartbreak. Sorry, Michelle. करेंगे इंशाल्लाह. करेंगे करेंगे. Sir, you look like Zayn Malik. और मर मर जाओ कहीं यार. You look like Zayn Malik. Zayn Malik क्या बदसूरत है. क्या है अजीब अजीब. लड़कियां पागल हुई हुई हैं. आप तो लड़के और कह रहे हो जैन मलिक इस बे. शर्म करो. हैशटैग नो होमो. ख़त्म. मैं जाऊं जी, इजाज़त है मुझे. सर, organic feels more realistic now. It is realistic and it's easy. Will this get posted onto YouTube? Absolutely it will. Absolutely, I'll post it right now. अभी बस recording ख़त्म करके I'll post it right now. Can you give me a tip if I want to pursue CA after A levels? Please do not pursue CA after A levels. क्या करना है, पागल वागल हो गए मोहम्मद. पागलपन मत करें. मेरी तरह पागल बनने फिर कर लें. फजूल है, कोई ज़रूरत नहीं है. जाएँ कोई यूनिवर्सिटी लाइफ एंजॉय करें. वी हैड नो यूनिवर्सिटी लाइफ. You're gonna dread it. I'm not saying it's a bad career option. It's just like we had no, why am I so open with all of you? You know why I'm so open with all of you? It's because I love interacting with people. I love interacting with you all because I never had a uni life. So why didn't you do ACCA? Because ACCA is very easy and it's very stupid to do. ACCA वालों को हम घास भी नहीं डालते यार. उनकी नॉलेज बेस और हमारी नॉलेज बेस में बड़ा फ़र्क होता है, और ACCA वुड एग्री टू दिस। इफ़ दे डोंट आमने सामने नहीं आए, मुराबहा कहते हैं उसको, कि कुछ कर लें। मुराबहा नहीं, मुबालिगा, मुबालिगा कर लेते हैं, बिकॉज हमारी जितनी डेप्थ इन डेप्थ अंडरस्टैंडिंग होती है चीज़ों को, उतनी ACC वाली की इधर नहीं होती। मुराकिबा नहीं होता, मुराकिबा मुबालिगा होता है। डन गाइस, चलो, लव यू ऑल। यानी कि why did you choose it after studying science? Because my dad wanted me to. That's why I didn't go to Imperial. Alright, guys, one guy had to stay behind to look after everything in Pakistan. Bye. Bye.